Well, good morning, everyone, dear distinguished guests, colleagues, and friends. For those who many years they know me as head of safety, I'm Tony Licu. I'm currently the acting head of technology division and head of digital transformation office in the network manager. It is my great pleasure to welcome you to the second edition of the FlyAI Forum. It's a full house, and I'm pretty sure it's a huge attendance in the streaming event that we have. Today we gather on the theme of exploring the exciting and rapidly evolving field of artificial intelligence and its application in aviation. We are in a hybrid environment, hence we need to be very tight. It's imperative that we stick to the timings. You see we have an impressive line of speakers in all the sessions. So the moderators will have a difficult time to keep on the agenda, but we need to because there are thousands also looking at us in streaming. So also, please, when you take the floor, also for the Q&A, press the button and then use the microphone so we can be here in the streaming. Before we go for a more final opening, I want to solicit a minute of your attention on the health and safety logistics, and we'll see that with the video. Thank you. Also, for any further assistance regarding logistics, what have you, our organizing team is available to help you, either in Europa lobby or as you have seen in the video. As we stand at the forefront of technical innovation, it is crucial that we come together to share our knowledge, experience, and ideas. This forum provides us with a unique opportunity to do just that. And I'm impressed to see how every year, we're in the second year, and how much, growing interest it is, and how full is the Europa room today. And I invite the EUROCONTROL staff, if you see the more people external coming, so please take the seats in interpreter booths. I am confident that the discussion and presentations that will take place over the next 2 days will be both informative and especially inspiring. I hope that you'll take all advantage of this opportunity to learn from one another and to forge new partnership and collaborations and network. We have an amazing range of speakers and sub-themes, as well as an array of stands that will display most of the products that will be presented in plenary. Once again, welcome to EUROCONTROL FlyAI Forum, and I wish you all a productive and enjoyable event. With this, I want to pass the floor to the first moderator of the first session, which is about research and innovation, Ruben Flor of SESAR 3 Joint Undertaking. Ruben is there, the Technology and Strategy Officer. Ruben, the floor is yours. Thank you.
Thank you, Tony. Welcome, everyone. I'm very happy to see so many people here. Indeed, the whole morning will be about research and innovation of AI. And I do have an impressive lineup of speakers. You see them all here, and it goes all the way up to Gabriella over there. So the time is on. Actually, we have a timer here counting down every time with everyone having just a few minutes. Let's see if this works. Okay, good. We're going to start in a moment with a keynote from our executive director of the SESAR Joint Undertaking, Andreas Boschen. He's sitting over there. We'll invite him in a moment. Then our speakers. So it's actually immediately I'm going to wake up a bit your own intelligence because we have a bit of a complicated structure. So we have a panel which consists of Romaric Redon, the AI leader and the chief operating officer of ANITI, Richard Cannon, principal investigator, R&D NETS, Alessandro Priester as the program manager for the AI flagship from SESAR Joint Undertaking, Camille Anoro and Benjamin Cramet, both representing here the Network Management Innovation Hub. And then having said that, Alessandro is bringing with him another 4 speakers embedded within his speech, which will be presenting pitches. So these are going to be very short pitches, 3-minute pitches on a few of our projects. So in order to give you a bit more of a flavor instead of just giving a list of all the projects that we have. And with that, I think, why is my not responding? Yeah. Andreas, I give the floor to you.
Thank you, Ruben. Good morning to all. A bit ahead of schedule, which is always good. I'm very delighted to be with you today here for this FlyAI Forum, and it's an impressive list of partners behind in the organization. EUROCONTROL hosting us in this big room, but we have also the Commission, EASA, ASD, CANSO, EDA, EUROCAE, IATA, IFATCA, IFATSEA, ACI EUROPE and NATO. This is my list. I hope I didn't forget anybody here. And I'm happy to see so many of you and your high level of interest in this event about the potential of artificial intelligence, what I would say for a sustainable and smart aviation sector in Europe, because this is in the end what we want to achieve. We want to have aviation in Europe as an industry which is smart and sustainable. So let's look a little bit back in the past about key innovation milestones in aviation and air traffic management. Well, it all started, as you know, 120 years ago with the brothers Wright, the first to fly successfully an airplane. And we needed 20 years before we all were clear we needed air traffic control. And the first controllers started sitting in a tower at Croydon Airport in 1922. And they had a radio and binoculars to improve safety for aviation. And we made a big step 30 years later in the 50s when we had radar, and then we could move from procedural separation to tactical separation. And then maybe another big innovation leap happened at the end of the 90s, on the middle of the 90s, when we were able to do network management in Europe. And here in EUROCONTROL, we established this European Central Flow Management Unit. So in 120 years from initial flights by the brothers Wright, where are we now? 30,000 daily commercial flights in Europe. Summer peak time, the network manager knows better than me. Paul, you know, 37,000, maybe even more. 40,000 will come. And I'm not looking at military, I'm not looking at general aviation, I'm not looking at drones, I'm not looking at whatever else, air taxis and so on. So the only way to handle this increase of capacity and even complexity, it means we need innovation and technology. Otherwise, we will not manage. And this is a bit what we are doing, the SESAR joint undertaking, at least when it comes to air traffic management, because we are a joint undertaking as a public-private partnership to modernize European air traffic management. We are trying to coordinate all the research and innovation efforts in the European Union. And my message to you, and maybe to help you for the first panel, Ruben, we can do, and we have done so far. We have delivered 136 solutions which are ready for market uptake, and we are pleased to see that many of them are in deployment and many more are in the pipeline. So innovation in air traffic management requires this thorough research and testing, and we have to demonstrate at every step of the innovation pipeline that what we deliver brings improvements to safety, capacity, the environment, and the efficiency. Safety, of course, remains a top priority in everything that we do, and I think nobody in the room will make a compromise on this. We have an issue with innovation in air traffic management and aviation in general. It is notoriously slow despite all our efforts to accelerate it. And then we look at artificial intelligence, it's anything else but slow. The speed is dazzling, and the speed is even accelerating more and more. So that brings us to the question, what can we do? How can we cope? So we look back, we were established 17 years ago. Artificial intelligence 17 years ago, machine learning was there. But many, many other things were not there. New techniques like deep unsupervised learning, they were just at the horizon. AlphaGo Zero, based on reinforcement learning, had to be born. And now, where are we? We take our smartphone, We have ChatGPT and whatever else, and we can all use it on a daily basis. We have knowledge graphs which have come to our life. We are using large language models which are changing our world. It's amazingly easy to access an almost infinitive amount of knowledge. So we as ADM, as aviation community, how can we keep pace and how can we benefit from these technologies? And how can artificial intelligence support safety in aviation? From our side in the SESAR joint undertaking, our approach to the different research project is to look very carefully at artificial intelligence and assess the opportunities. And then we are addressing also trustworthiness, transparency, and safety assurance. And these considerations are driving our research and collaboration with our partners. And the alignment of our research with the EASA AI roadmap and the AI concept paper are testimony to this. Let's not stay in silos. Let's work together, and otherwise we will not make it. Already over the last decade, we have seen how machine learning application can help us to optimize our ADM systems. We make them greener, they perform better, they become more resilient. And let me give you just one example, and I'm sure the experts afterwards, you will have many more. We can use now machine learning for highly reliable automatic speech recognition in air traffic control, where we are combining the language models from the AI with the airspace and radar data from the ADM. And we started this with an exploratory research project called Mallorca. Sounds very interesting as a location. But then we matured it, and another island comes in. We had industrial research project, which was called Hawaii. Again, very interesting. Then a more trivial project name was PG-1096, maybe also an island or a star, I don't know. But I mean, what counts in the end, we have now a solution which is deployed by several air navigation service providers across Europe. So research from exploratory to industrial to validation to deployment. And if we look in the context of the use space, artificial intelligence is definitely a key enabler for safely operating the projected drone traffic in our urban and rural environments. What will we have? Hundreds of thousands of flights, millions of flights, of missions daily operated all across Europe? How do we cope with this without artificial intelligence? I'm very delighted to see some examples of our research and innovation on display today in the exhibition and also in the conference program. So let me say, we are only at the beginning. You said, Tony, it's a second AI event. I think we need many more. There's so much more to exploit and to explore. And currently, we are in the process of updating the European Air Traffic Management Master Plan, which defines the modernization of air traffic management until 2040. So really a long-term picture. And we are right now refining and expanding our vision for a digital European sky, where automation and artificial intelligence are the key levers for the transformation of ATM. Artificial intelligence will support and accelerate the implementation of higher levels of automation. We need artificial intelligence to manage the huge amount of data which we are collecting in aviation and which we are willing, I hope, which we are willing to share to improve our operations. So good teamwork and trust between the human operators and the artificial intelligence agents is a key within this target vision. AI is supporting the human operators, taking over routine tasks, detecting potential issues, and calculating and suggesting mitigation options. To conclude, for us in the SESAR joint undertaking, there's no doubt that artificial intelligence holds great promise for air traffic management. In 2040, hopefully we are all still there, which is the target end date for our master plan vision. Then I think we will look back and we will see that artificial intelligence has been a key innovation milestone in the history of aviation, in the history of ADM, and it has contributed to a digital European sky, which has made Europe the most efficient and environmentally friendly sky to fly in the world. With this hope, I wish you an excellent AI forum, and I leave you now in the capable hands of my colleague Ruben and all the panel members, and I wish you a very, very interesting and pleasant day. Thank you very much.
Thank you, Andreas. before we go into a deep dive on all the technologies, I thought I'm going to wake up your imagination. In particular, because AI, it's not straightforward at all how to use AI in a safety critical context. So last week I was back in college actually, in the University of Leuven, and doing a course on the current trends in AI, learning about generative AI, knowledge graphs, edge computing, and then I got totally lost in the technical details of MLOps. And my mind started wandering around. So I started playing with DALL-E, with ChatGPT, and I thought, you know what? Let's make better use of my time. I'm going to prepare the conference of next week, which is now. And I thought, you know what? I'm going to ask DALL-E what it would come up with if I ask how to train trust when our lives are at stake. And this is what it came up with. If it works. Yeah. No, too fast. There must be one before. That should not have happened. The other way. Somehow this doesn't work. I don't understand it. One back. I think, yeah, we need a new battery. Okay. So unfortunately, a bit of a spoiler. I hope no one read too fast. Because I was trying to wake up your imagination. So don't read it. How to train trust when your life is at stake. So this is what DALL-E came up with. I didn't instruct anything else. I just asked this question. And in my view, this is interesting because what we see is AI is this giant animal, which is for sure it's going to be super powerful. No one will doubt that. But the question is, it's going to eat us or is it going to be on our side when we fight? And I think that's what the challenge is. We need to find a way to have it aligned with the objectives that we have instead of killing us. And then I thought, well, a picture is nice, but just let's take it one step further. I'm going to ask DALL-E, what do you think? Not DALL-E, ChatGPT. And then I asked it to do it in the words of a poem. So here it comes. In skies of steel or halls of care, where stakes are high and dangers flare, we train in simulators where time stands still to face the challenges, to test our will. In scenarios crafted with pressure rife, we learn to trust, to navigate life. Teams building binds us hand in hand. In unity, we firmly stand. Clear roles and responsibilities guide our way in the heat of battle, in the light of day. Cross-training arms us with knowledge wide. In each other's shoes we confide. Debriefing sessions, reflections deep, fuel our growth, our promises we keep. In a sanctuary of psychological grace, we find our voices in this sacred space. Continuous training, an eternal quest to be our best, to face each test. So let us embrace in this journey we trod the power of trust, the bond of our squad. For in the face of peril, where life's at stake, it's trust that holds firm, it's trust we make. So some of you may have understood that even though it's a poem, actually there's a lot of structure in it. And I asked the same, can you now write it in JSON? And this is what the answer is. So I cut it because I don't want to spoil the rest of the presentation. Thank you. I think this is what I would say is the theme of this morning, which is how can we trust AI to protect our lives? And with that, we go to the first speaker. And finally, my button works again. I'm happy. Romare Credon, Aniti, the floor is yours.
Thank you, Ruben. So it's my great pleasure to be with you this morning. Good morning, ladies and gentlemen. So I am Romare Credon, and I am the Chief Operating Officer of Aniti. I've been into the AI business for quite a while, 24 years, and all dedicated to research and innovation on AI for aeronautics, defense, and space. I spent 24 years mostly working with Airbus on applying symbolic AI, machine learning, deep learning, and recently generative AI for aerospace. And I joined lastly, end of last year, ANITI. ANITI being the AI Research Center, which we have in Toulouse as the Chief Operating Officer. And this AI Research Center, as you may guess, is doing a lot for aerospace. So just some quick notes about ANITI. So ANITI is the federation of all AI education, research and innovation activities performed by AI labs in Toulouse. So later on, you will see stuff coming from some of our partners because we are gathering all AI activities which are, for example, performed by well-known institutions in Toulouse, such as ENAC, EASA, but also industrial partners such as Airbus, Thales, Safran, and some others. So the idea of ANITI is to be more efficient working together in this research institute. And also, we are now about to be 120 researchers with the same amount of PhD, and also seconded engineers coming from industry. And our main topic is really development of performant and trustworthy AI application, because we are targeting critical sector of application, such as ATM, and we need to ensure we have the right level of trust in what we do with AI. And this is the primary topic for ANITI. We also have dedicated activities linked to ATM. So we have a specific share which run over the past 4 years, managed by Professor Delahaye from ENAC, where we had 27 PhD on the topic of AI on ATM. And I think some of the topic will be presented during this forum, at least from Aurélie, for example, from ENAC. This was also something done in the context of ANITI. So my presentation is about trends. Yeah, what are the AI trends? So for sure, I will start with this kind of view, historic view of AI, where we had different summer and different winter. It's all of that started with symbolic AI quite long ago. And then we had the rise of machine learning. And then we had also a lot of data, a lot of compute, and we went into deep learning. And now we are with generative AI. And all of that is in really acceleration at the moment. I've also put there operational research, which is quite important for us. Sometimes it's discussed whether it's part of AI or not part of AI, but it's definitely something very important to us to solve all optimization problems. So now we are with what could be considered as the third wave of AI, which is generative AI. But we are still using all AI approach. So this is a picture performed by DALL-E. The idea is that these waves, each wave is not erasing the previous one. So we are composing today with symbolic AI, traditional machine learning, deep learning, and also generative AI. And we really play with all these tools so to achieve the challenge and we have in aviation. So what do we do with AI? So here I try to give a summary of what we do, giving some illustration. So first of all, we will use AI to help us to perceive the world, to make prediction, to generate some content, and ultimately to do decision support. So if we go on the perception task, so for sure we will use AI to make sense out of images, and we will see example like detecting a runway or detecting contrails. You will use AI to do pattern recognition, time series analysis, tabular, also analysis of tabular data, for example, to do predictive maintenance. We'll also go for natural make sense out of text or speech. On the example I took there is Notam decoding or Notam encoding, by the way, where we are doing interesting stuff with AI. So then on the topic of prediction, we could use AI to really improve aerodynamic optimization of aircraft. We can use also AI to build surrogate models, which could be embedded inside the aircraft. So here the example is to embed the ACAS XU collision avoidance function. We can use a neural network to be a surrogate model and to embed this function, even having tiny computing capacities on the flying platform. The new stuff is really the generation. I was there last year, and this topic of generation was really in infancy, and now it has grown very rapidly. So as of today, we can now use large language model on all generative AI tools to generate incredible images. So I've took one which is representative of our conference. This is what DALL-E is doing. And more seriously, I put there something about Notam, because I asked ChatGPT to generate a Notam, and he invented, I got something, a crazy Notam about something happening on JFK. I also asked ChatGPT to encode this Notam. So this is the result of encoding. It's too small, but this is the encoding of the Notam. And yeah, this raised question, we will see. I mean, ChatGPT is always providing an answer, not necessarily something which we can trust, but you can now play with these generative AI tools, and everybody can play with these generative AI tools, and this is something we need to manage and really to take it as an opportunity and use it to improve our operational performance. The last topic is about AI for decision support. So here, for sure, AI is very good at solving allocation problems, especially dynamic allocation problems, sequential, generating planning. So that's one area where we have been using a lot of AI on operational research, and combined, by the way, machine learning with operational research techniques. And here I'm just highlighting, we have a specific chair that is for the use of AI, especially targeting sustainable air traffic management inside ANITI with ENAC, but also with a lot of other European and worldwide partners. So we have an impressive increase of performance. And here I'm putting a chart where you see this augmentation of the performance, and we achieve already today superhuman performance on many activities, on many tasks. And this has been highlighted with, if you look back, starting in 2011 with Watson technology beating players at Jeopardy games, then detecting object in image, then beating Go players, beating StarCraft players, and we have now ChatGPT, and more generally a large language model which enables to have a really natural language understanding capabilities which are sometimes beyond human capacities. So really an increase of performance, but the question is, what about trust and the compute and data requirements? So here I put some curves. So the orange one is the same I shown before, so it's the increase of performance. But also I've put a gray one for the compute requirement and the data requirement. And we do have a challenge because the compute and the data requirement are growing almost exponentially and even more. So at the moment, all what we do with generative AI is really consuming a lot of energy. So that's raised a lot of questions. Also, if we look on the topic of on trust, in fact, at the beginning, we were very confident about the result where we were doing symbolic AI. Symbolic AI, the rules are given by humans. They are encoded, but they are given by humans. So we can really, the system is doing what the humans are asking for the system to do. You can draw a direct line between the specification and the implementation, which is no more the case when you use machine learning. And that's the whole purpose of also the topic we are addressing with EASA on really building learning assurance. So somehow this line of trust, I mean, we've gone from something where AI were not so performant. We had not a lot of data on compute, but we were very confident about the result, to a world where AIs are very performant. We have huge data compute requirement, and we are not so confident about the result. So this really builds my request on really the need for developing trustworthy AI and frugal AI. So what is frugal AI? Frugal AI is AI that will need less data on compute. Of course, I've put there a question mark for quantum computing, because potentially we could have quantum computing coming, and this will be a nice fit with this exponential growing demand of compute. So if we have quantum computing coming to maturity, this might be an answer, but also we should not only count on new ways to afford more compute. We should also develop AIs that are interestingly requiring less data or less compute, and this is frugal AI. So I will give you just example of what we do inside NET regarding trustworthy AI. So regarding trustworthy AI, I took an illustration on the topic of runway detection. It's one of the use case which we have built. By the way, the data set which is used is open source. So you can use it also in your own research, this data set about runway detection. So we've developed trustworthy AI tools, for example, showing how we can improve the explainability of the prediction for the runway detection, how we can understand what are the different bias and how we might correct them, how we can deal with uncertainty management, how we can do out of distribution monitoring. So it means making an analysis that when you are making a prediction, you look at your input data and you look whether you already have seen such input data in your training data set. And if you have never seen such data, the best stuff is to discard your AI system, because your AI system is likely to say silly things if you have never seen something like what you were seeing. And this is out of distribution monitoring. Also increasing the robustness against adversarial attack, because I think you have seen you can fool an AI by doing some kind of random noise in an image. And if we've proposed some approach which are based on one Lipschitz network, which are much more robust to adversarial attacks. So if you want to create a runway, it's a fabrication attack. That's the last picture. You see that the shape you have to put there is really the shape of a runway. If you want to do a vanishing attack, so if you want to erase the runway, you really have to remove some very interesting pixels from the image. So the main message is you can no more do just a random noise and you will fool your AI. You have really to make tailored attack. And this is the kind of stuff we do. Also, this is an illustration in the visual domain. It's more easy to get the understanding, but we are active on on text. For example, we have a use case on Notams where we want also to provide explainability, robustness on Notam decoding. And more generally, we are working on the topic of trustworthy AI associated to generative AI, because we have this marvelous stuff coming from generative AI, but we can trust them. Then about frugal AI, I just want to point that two of our distinguished speakers came to World Economic Forum. One asking for a new way to produce energy, Sam Altman, CEO of OpenAI. So in his mind, it's really we need more energy. We need even new ways to produce energy. And we have Yann Lequin, one of the father of deep learning, which is really more advocating for a more efficient way to learn that would need less compute. What we do in NET on this topic is we are really still this is quite upstream research, but we are looking into neuro-inspired, more frugal approach. The main topic is that the way we learn as human is we don't learn only with text. We learn with multimodal experiment. And especially we learn a lot before we can read. So there is a lot we know about world model before we read. And this is about how you can gather all this knowledge acquired through multimodal experiment when you learn. And I won't go into the detail, but this is inspired from the concept of global workspace theory, which is the way the brain is working. So with this, I will end. And yeah, I'm very happy to be the first speaker. I hope you've seen a lot of what AI can bring to aviation, but also the challenge in terms of trustworthy AI and frugal AI, which we have to face. Thank you.
Thank you very much, Romaric. I think it's also a bit of reassuring that actually we're at the moment still learning faster than AI. I'm happy to hear that. Yeah, so let's go to the next speaker. The next speaker is Richard Cannon from NETS. And I think you already made the first intro to go to the how can we trust it. So I'm really looking forward to get your explanations on how we do that in NETS.
Okay, no pressure. Good morning, everyone. First and foremost, thanks to FlyAI for inviting me here today to talk about Project Bluebird, which is our AI project, our showcase AI project that we're working through at NATS UK at the moment. My name's Richard Cannon. I'm the principal investigator at NATS. We've already touched on some of these points today. However, I will give as much as I can. It's a very large program of work, but I'll give you a flyby tour, if you like, of some of the more interesting components of the project. I'll touch a little bit on the UK strategic landscape, the pressures that we experience there, very similar to those that we've already heard about today. Talking a little bit about modernising our R&D capabilities at NATS and preparing ourselves for moving into this kind of AI space and exploring AI, the risks and the opportunities that provide, and how do you answer some of those trustworthy questions. I'll talk a little bit about Bluebird itself, its aims and objectives. And I'll pick out just a few features of that. I'll pick out a feature called Common Task Approach, or Common Task Environment, which really helps all our researchers get together and work on common challenges. And I'll talk a little bit about building and testing air traffic control agents, which is one of the key objectives of the work. And I'll bring that together in a summary. So, in short, we have a number of pressures on our operation, as we all do across Europe. We have that need to obviously serve our customers. We have back to traffic growth again, so we have that 2% per year, looking at very large traffic increases, and do we have the systems in place to allow us to manage that growth? We also have our own Jet Zero strategy from the UK government. We're looking at net zero aviation, decarbonisation of the aviation network by 2050, and the pressures that come with domestic flights and airports also. So there's a nice pressure there. Our UK airspace modernisation strategy. All airspace in the UK is changing. There have been vast swathes already changed. We've just rolled out changes last year on West End airspace, but all the airspace will change to make it quieter, more efficient and more safe. We have the new government Future of Flight Action Plan, which has some really interesting challenges embedded in there. Things like BV loss routine for new airspace users by 2027, eVTOL routine for crewed traffic by 2028, and looking to support trials going forward. So these are really, a really tough landscape, but what a time to be an ATC, an air traffic control researcher, because these are some really terrific challenges. So what about capabilities? So at NATS, we've enjoyed working in SESAR very much over the past 15 years, and we've excelled at, just as we all have, at modifying and developing controller concepts on these in-house multi-purpose simulation platforms, really the same simulation platform that we train our air traffic controllers on. And that's worked really well. In fact, we have SESAR concepts that have made it through into the option floor. This is fantastic. But the AI challenge is slightly different. We have to be able to experiment with technology across the automation scale, not more just an incremental change in the workload of the controller, but we want to experiment. That is not to do, but certainly to experiment with high levels of automation. We find that it's quite prohibitively expensive to try and scale these simulation platforms for that purpose. So we have to think a little bit differently. And we also have to bring in real world conditions. So we can't just be working on simulators that we've used to potentially train our ACOs or to do these early validations. We really need to bring in all that noise from the real world. It makes a big difference when you're training agents to do aspects of air traffic control. So we find ourselves a few years ago not that well positioned to look at the risks and opportunities of artificial intelligence. Access, but not the kind of access we'd like to the real world data that we have from our option floors. And we were inhibited a little bit from pursuing those high quality studies. There's no industry sandbox at that time. There was no industry sandbox available. But what we want to do is position ourselves to guide the technical and process standards, to meet the regulatory compliance, and to deliver those challenges that are set out by government. So Project Bluebird itself is business-led and co-created. We have the pressures from government. We have this need to think about a capability change within in-house at NATS. We've also done some pilot work with the Alan Turing Institute, the UK National Institute for Artificial Intelligence and Data Science. And we've identified through some research with them that we do have some fundamental and applied technical challenges to overcome to use some of these algorithms at higher levels of autonomy. So we're talking about decision-making with uncertainty. Do we have enough tools in the toolbox to help us overcome those challenges? And the answer was not really. We need to do some fundamental work. We need to do some breakthrough thinking as well. We need to change the mode in which we do our research. And for that, we end up with what is sometimes called quite a courageous objective. And I want to explain myself on this courageous objective. To deploy an ACO agent that can perform safety-critical decision-making in shadow mode trials at a NATS unit. Now, that's a very courageous ambition over a 5-year programme. But that's not to say we want to replace the air traffic controller. Absolutely not. Quite the opposite. This is about understanding the full work of an air traffic controller and looking at the risks and opportunities of bringing AI assistance to each of those different tasks that the air traffic controller does. So the programme itself is 40 million EPSRC Prosperity Partnership. It's between ourselves, NATS, the Alan Turing Institute and the University of Exeter. It brings together quite a lot of disciplines, as it should. Mathematicians, engineers, data scientists, safety experts, high-performance computing people, project managers and validation as well. So there's about 40 people day in, day out on this programme, and we engage a lot with local universities in the UK also through internship programmes and studentships. So a little bit of a flyby tour, really, rather than delving down too much into each of these themes. But the Project Bluebird itself is set up on 3 themes, 3 thematic research. It's the construction of a probabilistic digital twin. So just relating back to new capabilities for experimenting with AI and new technologies. So we've chosen the path to where we use our simulators and we can complement the work that we do currently on our simulators in-house. Let's build something new. Let's build something new just for this purpose. And we call that a probabilistic digital twin. And I'll talk about that a little bit later. We also then talk about machine learning control. So we want to build ACO assistants that can perform some work of that air traffic controller. So we then bring in all the frameworks and all the data that's necessary to experiment with machine learning control. And then, of course, safety and trustworthiness is a stalwart of any research program that we're doing in this space. And that's the breakdown as it stands. If I was to be asked what would be the key theme or the key ambition for each of these thematic pieces of research, and I'm only allowed to say one, then this is what I would say. So the programme itself is broken down into 3 phases. We're in phase 2, and we build probabilistic digital twins and test agents. And by doing so, we create requirements for the twin again, and then we create requirements for the agent, and so on and so forth. And that's an iterative cycle that we move through. The trials that we do are all human in the loop. So we take technologies and we augment the work of the air traffic controller, or sometimes try to do the full work of the tactical air traffic controller in the sector. And that's how we experiment. So we've ran that 6 weeks worth of experimentation in July, and I'll present some of those results today. And we're heading for another large-scale simulation in November 24 to end in shadow mode, live shadow mode trials in February 26, which we're on track for. So a digital twin is a digital representation of the real world. My chart here is about moving from simulation conditions up into real world conditions. So we really want to give that those real world conditions to our agents so that they're training with all the noise and all the reality, or as much of that as we possibly can. And that's really important. We don't want to be training agents in these simulator worlds where we don't really see all those extreme scenarios or those differences in performance between different aircraft. So through the program, we work very hard to instill and build that data and modeling, that data simulation, and then those prediction models and making them better and better through the program. If I was to be asked, what would I expect from agents? I would expect to see a lot of agents. We want to do a lot of experimentation. We want to try a lot of different techniques. So as the project moves through, we build agents, and sometimes we discard them. They don't quite work. But at any one time, we're hoping that we'd be working on many agents at any one time and looking at the kind of potential opportunities again and risks of using those different approaches. We need a referee, and this is a really important part of the program. So how do we judge competency in each of these technologies? And we've done quite a lot of work in breaking that down. And what we've done is borrowed from the way that we train our human air traffic controllers today. So we've taken those curriculum-based learnings from a basic air traffic student license. We've looked at the curriculum in there. We've looked at the metrics for performance in there. We've looked at the advanced course and then, of course, the unit competencies. And we've broken each of those down and we've put those to task on trying to understand and mark, if you like, the performance of these agents. So it's a big program. There's 40 people on this program. It's important to take the best of what we know so far and adapting and using machine learning and research. And one of the really nice model that you can borrow is a common task framework. So a common task framework is a trustworthy building block. So these are common in machine learning, and it's just to say that we use it here too. A common task framework is setting out challenge. You set forward standardized challenge settings with standardized data sets with metrics that are accepted. And so that allows you to trial and test different approaches to a certain problem. And you know that it's being, you know what the data consumption has been, you know what the bias in the data might be, or the variance in performance based on all the metrics that you produce. So a lot of work on Project Bluebird has been to egress the operational data from the option floor. So although it's just a small box on the screen, there's many person years of work in here. So we take our physical air traffic control systems, our control of working positions, our airports or towers or military traffic or surveillance, and we get that onto a place where our community can access that data. We then constitute this, what we call this airspace digital twin. These are our probabilistic models. So we use all that data to build better predictors, and we put that into a probabilistic context. So we've now got a representation in the lab of what it's like in the operation, insofar as possible, noting that we try and invest and make that better and better through the program. For this example, and for my explanation today, we then trial lots of different methods for performing that role of tactical air traffic control. So what we do is we take out different frameworks, we approach different methods, and we put those into the digital twin. That allows us to test then. So that allows us to, if you like, to put the digital twin into the college, and then we assess the performance of each of these agents. Not only just assess the performance of its core competencies based on a human trainee, but also assess its performance with respect to computation, kind of computing time, how much data did it take, ingest, and so on and so forth. So what does that give us? If we put all that together, it gives a really nice way of experimenting quite quickly with different approaches to machine learning and so on and so forth. So from the left-hand side to the right-hand side on the screen, we have on the left a rules-based system, in the middle an optimization, A-star type system, and on the right-hand side a reinforcement learning agent trying its best to learn how to do avoiding action by the looks of it. So on the left-hand side, the rules-based agent, it's very explainable. So it's very good. But it's not very performant. It does tend to struggle with, say, traffic levels that you might experience today. In the middle, we have optimization. So you have a balance of flexibility and transparency, of flexibility and explainability. And this is a model that's been run by Queen Mary University at Stansted Airport. And you can see that it copes very well with different types of constraint and lots of uncertainty pushback. And on the right-hand side, we're really in a black box environment where we're using reinforcement learning, but we have a really super flexible tool, and it is very performant. So I wanted to touch very briefly, without running out of time, Ruben, on reinforcement learning. The slide says reinforcement learning, but what the slide really says is working in a multidisciplinary team and bringing the strengths out of that multidisciplinary team. So at the very start of the program, many years ago, we tried reinforcement learning to do tactical air traffic control, and we threw it away quite quickly because we just couldn't get the reinforcement learning algorithm to work well. Now, reinforcement learning is really about trial and error. It's about an agent that measures it observes its environment. It takes actions in that environment to receive a reward based on some performance criteria. So it's really doing trial and error. It balances exploration with exploitation. It tries to find new optimal strategies whilst also improving its own strategy to give the best results. So we thought this was quite promising. So we tried that. We used lots of training, and we got what the type of air traffic control that I might do on the left-hand side. It's not really staying inside the VOR. It is trying very hard to maintain 5 miles. It's doing a very good job of maintaining 5 miles, but it's not really orderly and expeditious. And this is true, what I'm about to say is actually true of all the different techniques that we've used on the program: behavioral cloning, genetic optimization, derivative-free optimization. You start to see a change when you start to bring in the air traffic controllers. You start to see a change when you bring in the domain expertise. You start to see a change when you start to train that system in a way that is more akin to how an air traffic controller does the work. So as you move across the screen, what we're doing is we're instilling some of that air traffic control expertise. You go from an absolute frame of reference to a relative frame of reference. That's like saying, how far apart are these aircraft rather than where is this aircraft with respect to a waypoint. So you start to get these performance increases. You can do short and long-term training. You can train for tactical separation, but actually, if you do the training correctly, a little bit like we do with the controllers in the college, you can start to see reinforcement learning strategizing, thinking ahead and planning for the sector. So all of these advances are actually from the reinforcement learning engineers working tightly and closely together with the air traffic control experts. So this is the same across the entire program. So this is really promising. So if we put it all together, what do we get? So this is the type of study that we get. This is an outcome-based study. So what we're looking at here is very high-level measures of, if you like, safe, orderly, and expeditious and efficient. Okay, this is operational data from 2019 on 2 sectors called London Middle Sector and London Upper Sector. On the left-hand side is the operational data. On the right-hand side is the agent performing the air traffic control within those sectors. So we put one of our agents, the optimization agent, it says it on it, and we put it to work on that sector. Now, this looks quite impressive. We don't do this for a few minutes. We don't do these for a few hours. We can do these for a few months. So we can take all the air traffic control data for a few months and test these agents in that environment. It's also quite impressive to say that there are no losses of separation. It's also quite impressive to say the efficiency marks that you get from this agent are not too far away from the efficiency marks that we get from air traffic controllers. But what we can't say is it safe? Have we ensured safety? So how do we do that? And the truth is, the program, as big as it is and for as long as it is, we're still in the classroom. So we're still trying to build competency-based training for our air traffic control agents. So we take everything back to the classroom. So what we've got here is London Middle Sector and London Upper Sector. We are going through a competency-based assessment routine. So competency-based training and assessment is like a blueprint for the controller tasks. It gives us access to all the key metrics for performance that an instructor is using to gauge and assess the performance of a trainee air traffic controller. And we found this tremendously useful in the program. So we found that if we can take some of that, decode, if you like, some of those metrics for performance, we can build better reward structures in our agents. We can look for better marking, if you like, for how would we ensure safety. So we're taking key competency questions really in a skills, knowledge, and attitude perspective to measure what is technical safety, or to assess technical safety, to say that does this agent have a safe operating technique? Was the vectoring appropriate? Was the performance judgment appropriate? So all of those competency questions that an air traffic control instructor would ask the student. And then we put our agents through that college course. So this agent here is in its summative exercise as a basic air traffic control agent. It's on an operational sector, so not quite a fair test. And it's just about got fully to mostly safe for that environment. This is our results from April last year. Certainly lacking on communications. This is a data link environment. We're not talking, unfortunately. But in the model, probabilistically, we're modelling all those aspects that you would expect us to model. We're modelling the time it takes to transmit to the airframe and for the airframe to respond. We're building models for the expected Met conditions against the actual Met conditions. We're building models for performance ranges of aircraft based on probabilistic models, probabilistic PCA or Gaussian functional Gaussian processes. So all of the uncertainties are in this model, and we're still able to take, insofar as possible, some quite good decisions. So it looks quite promising, but noting that we are very much still in the classroom. So in summary, we believe that by taking this decision to move away from our simulators and build our own capabilities to test, train and validate machine agents has really been a catalyst to research. Putting in a competency-based approach has allowed us really to build a really nice development culture, to give our scientists and engineers access to data sets very easily, and to build tools and processes together. We've lowered the barrier to entry as well with a lot of good training. And we now believe that we're in line of sight of some of those key AI challenges. So like how does machines work alongside humans? For the next few months, we'll be looking to extend it. Well, we have extended the digital twin to the UK FIR. We're looking at the performance of agents in extreme conditions, which is very important. So we're looking at the performance across extreme conditions and scenarios and managing the performance of that through the Common Task Framework. We'll go back in and do some basic summative exercises and advanced exercises for the agent, and we'll have this digital twin going live sometime over Christmas this year. So I look forward to coming back next year, and hopefully we'll have an agent that can pass some part of the curriculum. So thank you.
Thank you very much, Richard. That was really appreciated. I'm impressed with how many content you can put in 20 minutes. Well, 20 minutes and a few seconds, I guess. Spot on. This is a moment to remind the audience that you actually have a role to play. I'm not sure if you're aware, but the last 50 minutes are reserved for questions and hopefully some answers. So before you get totally overwhelmed, I would invite you to write them down because you will have forgotten them otherwise at the end. So just be aware, we have 2 more presentations plus 5 pitches to go. So you'll be drowning in questions at some point. So write them down because I'm expecting good questions. Having said that, Alessandro, you're next on stage with all the pitch speakers. So Alessandro Priester from the SESAR Joint Undertaking. We have Jason Gauci for the Astra project, Aurélie Peot, Aurelia Arnsen, and Gabriele Gigant.
Thank you, Ruben. Okay. So good morning, everyone. I'm very honored to be here today to give you an overview of the SESAR Artificial Intelligence Work Program. And we are in SESAR, we are very used to teamwork, and I'm very happy to have 5 projects presenting here today. And to give you an idea of more content, what we are aiming to achieve. So I'm program manager due on artificial intelligence at a flagship, and in the past 8 years I've been coordinating the exposure research program. So just a reminder, something that most of you already know. So SESAR GU has been set up already, SESAR 1, SESAR 2020, now SESAR 3. And as Andreas Bosch presented earlier this morning, we are going through the innovation pipeline. The aim of this innovation pipeline is to make sure that we'll not have again, as in the past, R&D projects that were delivering good research and then put on the shelf. So what we are taking care is that the research that is being progressed starting from export research, then in the industrial research, and finally in the digital sky demonstrations to achieve the highest level of maturity before deployment, will really be successful and will be moving to first industrialization and then deployment. So as we already have 136 solutions that have been delivered and validated. and are currently in the phase of deployment. So what are since the beginning of SESAR 3, we have also introduced the so-called fast-track innovation and uptake projects, which are starting typically from applied research and then progressively progressing through industrial research and achieving completing with initial demonstrations. This slide gives you an overview of the today projects in the SESAR 3 selected and launched from the previous calls. But it does not include yet the exploratory research projects that were selected for the latest ER2 call that are currently in the gap phase. And I'm going to deal today on the artificial intelligence, which is all the projects that are highlighted in red. Therefore, starting naming them: Synter, Trusty in the fundamental research, Astra in the applied research, Jarvis in the industrial research, and Darwin in the fast track. And as you can see, there are many other projects that are highlighted in red, but are not really dealing. They are dealing with AI, so AI technology is being used for delivering the solution, but they are in the different flagships. Overall, in the program, we have already started a close collaboration with EASA, and you will hear more this in the later session. What we're aiming to achieve is that, of course, as we are increasing the use of AI technology in the delivery of the solutions, we will ensure safety, and we will have, therefore, EASA guidance in order to ensure that their guidelines can be practically applied. We didn't start AI just now in SESAR 3, and these are the projects highlighted in red, in green. But we already have a lot of projects in the context of SESAR 2020 that have been investigating as AI technologies in fundamental research, applied, industrial research. So there is a lot that has been already done and that is being taken over in the current projects. So now dealing with the grouping of SESAR projects. So this part is very much mirroring presentation from Romeric, and I will give you some examples of how AI is being currently used in the different projects. So Trusty and Jarvis in the context of airport and tower surveillance, Astra, Harmonic, and Hypersolar will be that are targeting the delivery of flow management position enhanced with AI technologies, aiming to predict and resolve traffic hotspots. Then we had the project, so the blue projects are past projects and the green are the ongoing projects. So PJ9 has been delivering a solution based on AI for network state monitoring. Then the SMART's ongoing project dealing with a smart securitization of the airspace. A past project on PJ2 that has been dealing with optimized runway delivery using AI. Then we had a lot of work in the previous program by TAPAS, Mahalo, IASA, Artination, and other projects that have been investigating at the fundamental research level the explainability and transparency, which is a key aspect for using AI and in the future. And now we have Jarvis and Darwin, which are respectively industrial research and fast track, that will be dealing with these solutions and to implement human AI teaming. So human AI is going to be a core of the future use of AI. And there will be many more projects that will be starting in the new program, year 2 program. And these projects, Jarvis and Darwin, as you will hear tomorrow, will be delivering AI solutions to support the pilot in a single pilot operations and the ATC controller and the airport tower controller. Then we have FastNet supporting dynamic reconfiguration airspace resources. Synter, that is addressing the question of how to generate synthetic data when recorded data are missing for feeding AI machine learning. Then Kairos is an ongoing project that is taking benefit of a Isobar previous project, dealing with improved adverse weather forecasting and impact on network management. Then we had many projects dealing with use space, and then I would just mention now Bubbles, Giuseppe, and USpace that have been using already AI technology. And now the new project that will be presented later is AI for Hydrop, aiming to develop use-space advanced separation management services. I will also highlight, as it was also mentioned by Andreas in his speech, a success story of speech recognition, which started in Mallorca as a fundamental research, then Hawaii, and two industrial research projects, and currently being deployed in a space in Europe. Then we have Simbad that has been dealing with using AI for understanding airspace users' preferences and behavior. In the context of intermodality, we have ongoing Maya and Multimodex, which are taking over results from Emotep and Big Data for ATM, and dealing with use of AI for modeling passenger behavior. Then we had Synapse in the previous ER4 projects, which has developed a solution for monitoring the performance of the communication network and detecting anomalies using AI. Together with, and there were other projects that were dealing with ICT security as well. And last but not least, I would like to mention WhoCan, which is also an ambitious project looking to develop novel methods and procedures of certification using the AI guidance and to make them more practical and applicable to the SESAR projects. Some of these projects will be presented shortly by my colleagues. Therefore, you will hear the pitches from Astra, Hypersolver, Trusty, AI for Hydrop, and WhoCan. Tomorrow, you will hear a presentation from Jarvis and Darwin in different sessions. And of course, we'll be there in the exhibition area, and we'll be very happy to answer your questions later. Thank you very much.
Good morning, everyone. My name is Jason Gauci, and I'm the coordinator of the Astra SESAR project. So the Astra project is an exploratory research project, which is application-based, and the vision of our project is to bridge the gap between ATFCM, air traffic flow and capacity management, and ATC, air traffic control. And in particular, we want to bridge the gap between the flow management position and the planner air traffic controller. And we are planning to do this by focusing on tactical traffic hotspots, by predicting and resolving these hotspots, which are areas of the airspace where you have groups of aircraft in the same place at the same time, and which present increased complexity to the air traffic controller. To give you an idea of what we intend to do, our aim is to predict and resolve tactical traffic hotspots in en route airspace. So we are looking at a time horizon of 1 hour. So imagine this scenario, we have 2 area control centers. ACC1 is our area of responsibility, and we predict a hotspot. So the first thing that we do is to generate a hotspot alert to the FMP within our ACC. However, then we also propose a dissipation solution. In this case, the solution which we propose is to redirect an aircraft to waypoint Zulu. And we also propose this action to be taken at some time in the future, in this case, 30 minutes ahead. The dissipation solutions can be multiple, so they can be flight level capping, speed changes, rerouting, and also other actions. This dissipation solution, once it is accepted by our ACC, is then coordinated with the upstream ACC, where the aircraft has to be then rerouted so that the action can be taken. And therefore, with this method, the hotspot will be resolved. We believe that with this solution, we can reduce ATCO workload within our ACC, as well as increase en route capacity, safety, and efficiency. There are a number of techniques which we are using in this project, including supervised learning to help us with flight trajectory prediction based on historic data from EUROCONTROL and other sources. Generative AI to help us generate synthetic traffic data and hotspots to augment the historic data set, and also deep reinforcement learning to suggest dissipation solutions, such as flight level capping, speed changes, rerouting, and so on. There are obviously various challenges which we are addressing in the project related to machine learning. The first one is to exploit machine learning to reliably predict and resolve tactical traffic hotspots with a 1 hour time horizon. Secondly, to define robust traffic complexity metrics to help us detect hotspots reliably and confidently, and also to make the solution acceptable to the end users, who in this case are primarily the flow management position personnel. Over here on this slide, you can see the partners of our consortium. There are 5 partners from Malta, Inganav, DeepBlue, Skyguide, and Skysoft. Thank you for your attention.
Hello, my name is Aurélie Peau from ENAC, and I will present you HyperSolver project. HyperSolver is also an exploratory research project with the aim of bridging the gap between ATFCM and ATC as for Astra, but with a very different approach. Namely, we aim at building a solver, a HyperSolver, able, thanks to deep reinforcement learning, to provide debunking few hours in advance, but also to provide conflict resolution avoidance at short and medium term of horizon. Here you see a simplified view of reinforcement learning, may be useful for the non-AI practitioners of the audience. So just a few basics for you to understand. An AI agent is learning from a training environment, some objects, the state, the actions performed on the objects, and the new resulting states. And then it is comparing this with the rewarding functions, which are basically its objectives. Similarly, in HyperSolver, we aim at building the HyperSolver model based on neural network architecture, feeding with fast-time ATC simulators, where you will observe aircrafts, intense characteristics, and also actions performed on the trajectories, and also instructions from air traffic controllers. Then rewarding function, and that's the key in this project, should be tailored to match with ATFM objectives, but also ATC objectives at different time of horizon. And we have a huge work on this part. The rewarding function will be based on, of course, avoidance of losses of separation, but also fuel consumption optimization and trajectories optimization, especially at further horizon of time. Now, in HyperSolver, we also want to develop and provide a comprehensive project. And so we also work on what such an AI agent will lead in the operational working, in the operational room with working methodologies. And we also work on the flow-centric approach to provide control over a larger area and provide more room of maneuver for the HyperSolver agent. And we also work on the single controller operations, where you have today 2 humans pairing together to control aircraft. We aim at having an AI pairing with a human to control aircrafts. HyperSolver is led by Neomatsys and involves EUROCONTROL, Nanyang Technology University from Singapore, Warwick University, LFE, and ENAC. Thanks a lot for your attention. You still have me again, but you can applaud if you want. Thank you. Now moving to another exploratory research project on AI, but very different approach. It's TRUSTY, that stands for Trustworthy Intelligent System for Remote Digital Towers. In TRUSTY, we aim at focusing on human factors for AI. The aim of TRUSTY is to explore the trustworthy mechanism toward an AI agent. In our case, we have selected an AI agent for the ATCOs in the context of remote digital towers. So we focus on human factors for AI building block as defined in the EASA concept paper, but also AI assurance with the explainability topic, and also, of course, incorporate safety and ethics-based assessments. In concrete, in TRUSTY, we aim at providing an intelligent system able to recognize vehicles, objects, to ease and support the taxiway and runway inspection and monitoring on remote aerodromes. We aim also at providing to this system explainability and transparency thanks to human-centered AI approach, which integrates data visualization interaction, data exploration approach, and data storytelling, a lot of data again. And finally, we also aim at assessing the trust level of the operators towards this AI agent and the shift momentum in positive and negative way where it gains or rejects the tool based on neurophysiological and behavioral measures. In TrustRC, we have very high expectations and we have set ambitious objectives, namely the provision of a comprehensive framework to build trustworthy intelligence system for remote digital towers, including self-learning and self-explainability features, but also able to adjust to operators' state of mind thanks to cognitive measures. We aim at developing a proof of concept with an intelligence system able to recognize vehicles, to support runway and taxiway inspections, and to assess it through human performance in the loop experimentation next year that will be located in ENAC premises on Achille platform. Achille platform is a comprehensive simulation real airport environment. In our case, it will be Charles de Gaulle, involving controllers and also pilots for immersion. And we also have camera locating on Muret Aerodrome, which is nearby Toulouse, for the remote digital part. And finally, one of the big change also is to ease and contribute to the acceleration of the transition towards the remote digital towers, thanks to developing this kind of transparent, explainable intelligence system for the operators, namely in our case, the air traffic controllers. This project is led by, I hope I say it clearly, Netherlands Universiteit, and involves also Deep Blue, ENAC, and Sapienza. Thanks a lot for your attention.
Hello, good morning. So my name is Aurélie, second one. Okay, here. So I'm very pleased to be here. I would like to share with you some insight of our exploratory research with an exotic name, AI for Hydra. But first of all, I would like to share with you a vision of our architect that is working with us in a project. And he sees the futuristic cities where we can design a drone port, vertiport in very, let's say, sophisticated manner where we can see many drones operating in a safe manner. Safety. But before that, we need to address some challenge. All of us, we need to address some challenges. So I'm going to list the three of them, the most important in our project. The first one, since we expect to have a growing number of drones, so therefore we need to take into account the use space capacity. So for our project, what we are looking into that, we were looking in order to define the structure of the airspace and to define the best possible way, the flight rule for use space. To this end, so we wanted to explore, and we already start actually, so it's a new project from September, to automate some procedures, such for example, ARA, the Airspace Risk Assessment, to be able dynamically to activate or deactivate 4-day flight routes, and in addition to that, to strategically address the deconfliction. Another challenge that we're addressing in this project is about the drone flying in a restricted area or in a non-fly zone. So of course, this poses many issues. And for that, we're actually looking into collecting image from that. We have some data set and as well audio, radio frequency, in order to be able to define a combined model that will predict the drone detection with more accuracy. In addition to that, we would like to provide some AI-based mechanism in order to check actually that the flight conformance, it is within this specific drone. So, and the last one is about authorization of flight. Today is done manually, actually, and of course, with the increasing request and with the evolution of technology, we expect, of course, some safety issue. To this one, we expect to use AI in order to support the decision-making for the authorization process. We intend to, of course, to focus on fairness, priority, and equity of usage. In addition to that, we are looking into this very innovative approach, generative AI, large language model, because we are starting to develop AI, a chatbot actually, to help the drone operator to define their flight plan together in an interactive manner. Of course, when we are developing all these models, these AI models, we need to take into account some of the specificity or some ethics, actually, such the privacy, the security, and so forth. So I would like to thank, of course, Alessandro, but as well all the team here, my consortium. And if you would like to know more about our project, we are having a stand here over there. We are going to explain a little bit more about authorization plan. And we have my colleague here as well, Emre, from the Istanbul Turkish University. Thank you very much for your time and attention. Thank you.
Hello, good morning. And now I am the last of the exploratory research, the last one. You can fly with AI, we hope one day. So let me presenting just some thought on UCAN project. It's an exploratory research project. Here, the idea of UCAN is to provide an holistic and unified approach complementing what we have now. We started at our proposal with the EASA roadmap. The things went very fast, thanks to EASA. And so we had some research needs. Now we have concept paper that are addressing new research needs, and UCAN aims at complementing this, making them more applicable. So which are the main objectives of UCAN? The first part of the UCAN project is just to focus on the state of the art, on what we have, which technologies we are, which are the challenges on human AI assistant in aviation, on higher level of automation. Just let me highlight this, that you can look at AI, artificial intelligence, but the main objective is to complement, to support the certification approach for higher level automated systems, so higher level of automation, including also artificial intelligence. Which are the key pillars? The approach is the performance-based requirements, for example, the safety performance indicator, and the holistic perspective. What does mean? Just to join the human aspect, the human behavior, and include human AI teaming inside. The second part of the project is to provide the holistic approach and this kind of framework for certification of higher level automated systems, plus providing some preliminary guidelines, just means of compliance, how to comply with the new ideas. Is an exploratory research, so it's just a proof of concept, but how it aims to do this using 4 use cases. So the approach is use case driven, and which are the use cases? Dynamic airspace sectoring that leverages on genetic algorithms plus multi-agent simulations. It decides which sectors, which is the best allocation of sectors at tactical level. The ATCO digital assistant in TMA, it uses and leverages on deep reinforcement learning, and it supports controllers in applying the approach procedures, in this case, the trombone procedures, dynamic airspace reconfiguration of service for use space, leveraging on machine learning, and another system that leverages on a previous project, Argo, that is dynamic allocation of traffic between ATCO and system, that doesn't include AI, but it's just provide higher level of automation, which is the research team. Deep Blue is the coordinator, and then we have 3 research centers, NLR, DLR, and CIRA, and the flight EASA is on board. Thanks to EASA for joining with us. For major info, you can contact Paola Lanzi, that is the coordinator of the project, and all the VP leaders that are part of the project. Thanks a lot.
Thank you very much, Alessandro, and all the pitch speakers. I'm starting to see more and more links to the sessions that we're going to have after lunch. There are still 2 more sessions, one on regulation and standardization and one on improving ATM network performance. I hope you're starting to see the links because there are plenty. So you can expect that already the questions are being prepared now, Guillaume. Having said that, the next speakers that we have are Camille Amaro and Benjamin Kramer. The floor is yours.
Good morning. I'm Camilla Noro from the EUROCONTROL Innovation Hub in Brittany, working in the innovating and emerging activities. And I'm with Benjamin Cramet, who works in the NM Lab here in Brussels. After listening all these inspiring projects from different organizations, Benjamin and myself want to share with you how we found a way to work together from the concept level to the industrialization within one agency as one team. So to start, I will present you the innovation process, which is a user-driven process made of three main pillars. The first one is the connect. So in this part, our stakeholders come to see us with operational challenges and some ideas they would like to develop. They present it to our stakeholders community, and after a ranking of interest from our community and the feasibility study on our side, we select some project that will move to the next phase of the process, the build phase. In this phase, the EUROCONTROL team made of data scientists, prototype developer and validation experts work together in an agile process with the operational stakeholders in order to develop a solution, AI-driven solution. And then once this solution is built, we integrate it in our prototyping platform and we validate it with the users. This step is really important to build the trust with the users. And so once the validation is completed, we move to the last phase, which is the promote phase. In this phase, the idea here is to share the results with the rest of our community and hand over the whole project to the entities that would like to have this project. So it's NM, the stakeholders themselves, or the industry. We started this innovation program in 2020, and since then we are working with more than 70 stakeholders. So we are working with airports, airspace users, ANSPs, and NSAs. Currently, we have just started the 8th cycle that will run since April 2024. Since the beginning, we have our stakeholders have submitted 60 operational challenges, and we have launched 30 projects. Here is an overview of our project portfolio, the current one. So we have some projects that have just started. So they are in the scoping phase and in the build phase. So the scoping phase is really important for us. We are using a design thinking approach to really understand the stakeholders' needs, how they currently operate, and what would be the benefits of our solution. Then we move to the build phase. I mentioned we develop an AI-driven solution. We implement it in our prototyping platform. And once this is done, we go to the validation with trials. So there are some projects that are coming to trials in the coming months. Then some projects are already in trials since last year, and some projects have already completed their trials. Once the trials are completed, the project is validated, and the partners want to move to the next stage, which is the industrialization. Here we have some projects that are already operational and working in operational tools. Last year at the FlyAI Forum, actually, I presented the FADE project, Forecast of ATFM Daily Evolution. Last year, it was in the status of completed trial. We finished the trial at that time, and we were working with NM to implement it in their tool. Now, since May last year, it's implemented in the NMP flight application. And so this is how the usual process. Today, I'm going to focus on EDI, Early Diversion Detection System. So it's one of our projects that has completed its trial and is moving to the industrialization. If you have any questions and you would like to know more about all of our projects, we have a stand in the lobby, and we have all our data scientists today present on site, and we will be happy to tell you more about our project. So EDI, Early Diversion Detection System, it's a project that aims at anticipating the risk of diversion at arrival airports. To do so, we worked with airspace users and airports, and we built a machine learning model based on weather information. So we're using the weather forecast with the TAF and the weather observation with the METAR, depending on the timeline when you want to make the predictions. And the machine learning model provides a probability of diversion for each of your flights. So for instance, here you have a screenshot of our prototyping platform. At the right end of the screenshot, you have two columns, div, which is the probability of diversion for your flight, and div nature, which is the kind of information that the machine learning model took to make the prediction. So it's either the TAF or for the forecast or the METARs for the observation. We started the project in 2022. Mid-2022, we went for a live trial for almost 1 year to make sure that we had enough data and sample to make the performance assessment. And at the end of the year, we finished the trial, and now we are starting the last phase, which is the deployment. So this is the time now that I will hand over to Benjamin, and he will explain how this industrialization process works.
So hello everyone. Thank you, Camille. So basically, I am in the business of inventing the life that goes with the models. The models arrives, they are feature validated, but there is a lot of work still to do to make it safe and to introduce it into the ops group. So basically, you will feed your normal software development process with the ideas that comes. You can be inspired by SESAR, you can have promising projects coming from it in, and you can have your own ideas. This is still be allowed for you to have your own project and to fill it. Then you will enter into the normal IT, and then you will work on the ML ops. So there you may redevelop completely the model from scratch or implement it and automate it through ML ops. But there we are very much into IT, and then you will move on to testing. Then you move into conformity, compliance, and safety, and also training. So there you will go and turn a project that is industrialized in terms of IT. You will make it safe, and you will train the operational colleagues, and you will take also the tech people. There is a special things for the AI that may not be safety critical or may not be mission critical. So even if you are in this uncharted territory, there you may want to apply a certain level of safety so that you are sure that you can sleep at night, because I like to sleep at night. Then you move on to operation, you're done. This non-safety critical or this safety critical, there you rely on EASA, or you rely on other aspects that can help you with. And then you move on to operations, and for us, operation means INM. Up there, I wanted to show you another project that is stemming from SESAR. And this is why I call it SESAR, from SESAR to operation. And you may have seen it also briefly in a previous presentation, but there I will do the big full blown. So basically, we are working from the weather predictions. So there we have the weather prediction. Look on your screen. On the big screen, you do not see it well, but on the small screen, it is perfect. So there you have weather prediction. And from the weather prediction, we want to deduct immediately the impact on operation. So we want to know when there will be a reduction of capacity and how much this reduction of capacity will be. Basically, we want to insuffle or push confidence into the NMOC operators when they pick up their phone and call the FMP to say, hey, you may want to put the regulation now, because in 4 hours time, the weather will hit, and then we want to organize it. Then this is where we work. So this actually is iFlow, and I will come to this because this is the Trojan horse. So here you have the weather prediction, and the operator can right-click on the impacted traffic volumes and immediately see the capacity reduction. It is the purple line. So you say, Benjamin, all this for a purple line. Yes, but behind this purple line, there is a training, there is an AI that has gone through conformity and the safety analysis. We have trained the operator, we have trained the technicians, we are monitoring it 24/7. So we monitor the drift, we can retrain it, all this through automated pipelines. So yes, ladies and gentlemen, we are in MLOps and in safe MLOps. So all behind these purple lines, it is the arrow that I've shown you before. When I say done it, we are almost there, but it will be ready for operators during the summer. And basically, the story continues because Camille, you presented Eddie, and we received recently an email from the EMS room saying that there have been a problem around London and in Ireland. And if there would have been Eddie, the prediction of divergence, they would have started before the procedures. They would have loaded the diversion features earlier and be able to organize better the network. So Camille, Eddie is next. And I thank you for your attention.
Thank you very much, Camille and Benjamin. I am actually impressed that we're still on schedule. It's unbelievable. I hope you're not totally in overload and that there are some questions now. So we actually do have a minimum 15 minutes for questions. So who wants to start? Anyone? In the back there.
Thank you, Mr. Chairman. Good morning, citizens. I'm Angelos Harlaftis, Epaphos Advisors, who represent the Urania and Helios Space and Defense Group, a group which is working for the creation of the European defense community according to the Treaty of 1954. I'm working 14 years here in Brussels in artificial intelligence and 17 years in what today the system calls deep tech. So, of course, we don't need to speak for the benefits of the artificial intelligence. Only this we are speaking the last years, at least the last 50 years, which this science exists. But I'm raising a lot of awareness for our nature because we don't implement very simply the laws of Asimov, which they were applied during 1940, 1950. And there are very three simple laws. The regulatory framework, which a commission poses, cannot stop the GAFA, the 757 American companies, which they are working secretly almost to these things. So, and as you shown us the monster, the question is very simple. We cannot stop the monster, but why don't we create another 9 or 10 monsters? Meaning what I'm proposing to the citizens, to create the CNET, the European Internet, which is simple TCP/IP protocols, and then we can create our own monster, which can balance the monster of the Internet. So, and ending, I should say that we as Europeans, we have to follow another culture in the artificial intelligence and other things so that we can compete the existing framework. Thank you very much.
That is going to be a challenge, and I'm looking forward to one of the panel members to provide an answer. Who's willing to try? Romarek, I see your hand moving.
Yeah, I mean, this is the topic of sovereignty. On making sure we manage some level of sovereignty in what we do with AI. And I think, yeah, I mean, it's quite a big topic on, yeah, the European Commission is investing, the state members are investing to develop some level of sovereignty on AI, especially also introducing some AI frameworks. Which would be open source and available for all of us on providing more trust. On the topic of generative AI, for example, you have this Open LLM initiative pushing for having more transparency on the way you can use LLM, but also ensuring full transparency on all the data which has been used. What I can say is that on my side, I mean, INET is one of the research center trying to push for sovereign solution, especially on developing trustworthy AI methods that can be used and developed in Europe to answer notably EU regulation. After a lot can be said, maybe I don't know if colleagues want to complement.
Benjamin?
In terms of regulation, the EU regulation goes already in the right direction. It will not be a full wall against GAFAM and do not prevent us from using it or doesn't forbidden the use of GAFAM. But it is also something. It is a step in the good direction with the AI Act and other regulation around data. Also, nothing prevents you from using a European cloud provider. So you can run your AI on AI providers, on European cloud providers. There are sovereign solutions, and there are several providers of sovereign solutions. So actually today, you can have the same level of feature, and you can reach the same level with a European provider as with the Americans. So there it is a work for each of us in our organization to promote European solutions instead of American ones, should we want go in that direction.
Very much, Benjamin. Let's see if there are any other questions. I'm also looking behind me. I see a hand there. Yeah.
Thank you. Ignatius Cotet, Deutsche Flugsicherung, Germany. First of all, thank you very much for the presentations. I have a question, maybe it's a general question, but I think that maybe for Romaric and Alessandra, you were talking about synthetic data, the use of synthetic data. I think that Eurocontrol is doing a really great work centralizing all the data that we can use, and also with these B2B platforms. But the reality is that we have still not enough data, at least for us, for our algorithms. And I would really like to ask you, how is your experience using synthetic data for these critical models, for this in aviation, that we really need to trust in our data? So it's something that we were talking before, and we were thinking about to use this data, and I would really like to hear about your experience using this data. Thank you.
Alessandro, you want to go first?
Yes, so we have this project called Synter, that a fundamental research project that is addressing this big challenge of generating synthetic data for algorithms that will be using machine learning, where in the specific use cases where these data are missing or very scarce. The project just started, so it is still too early to talk about the lessons learned. But we will know more in 1 or 2 years when the project is finished. Maybe Romaric can complement.
Yeah, so we developed, synthetic data is quite useful, especially for building on the perception task. It's quite well known if you look in automotive, the way they are training their algorithm for their advanced driver assistance system, or to reach even higher level of autonomy. They use even much more synthetic data than real data. So we invested on creating a database, a data set with synthetic data for runway detection, because we clearly saw that many of the things we were doing based on standard benchmark were not convincing. So we had to build an open data set to really to work further on runway detection. So this is what we did inside INET, and we put it as an open source data set so that everybody can use it and enlarge it potentially. It's based on synthetic data. After the question is, we do that to improve the performance and to improve the trustability of some of our algorithms, especially for detecting, for example, the runway in situation where you would not have real data, because you will not fly an aircraft in these situations. And this comes to, I think, interesting discussion that may come with EASA. The question is how much you can rely on this synthetic data in the certification process. And this is a topic in working group 114. I mean, at the moment on certification of AI with EUROCAE and SAA to discuss how much we can rely on synthetic data, but definitely it's the way forward to improve the performance of some of the AI algorithm.
Sir, I think exactly. I wanted to put Richard on the spot, but he's already doing it.
Thanks for that. Yeah. Thanks, I'll go. So a few observations. I didn't manage to talk about synthetic data generation on our program, but to give you a scale, if you like, of the amount of data, we've about 20 million flight records available on Bluebird over the last 8 years. And I think the hints and tips from our work on it over the past 5 years are it's synthetic data is it's important to generate, of course, but the quality of the data that beforehand is absolutely imperative to get that right. We found ourselves falling foul, if you like, with lower quality data, unsuspected low quality data, and then that affects then the synthetic generation and the kind of training that you do on the agents. So we've got some lessons learned there. When it comes to synthetic generation, it's absolutely necessary for what we're doing. We're looking at exceptional scenario training. We want to understand the performance of our algorithms in these exceptional circumstances. We're not looking at nominal work or nominal conditions. What we're here to do to make sure that we provide support when it's needed, and that is when it's hard. And that's what synthetic generation is for.
Yeah. Okay, thank you very much. I think that's absolutely clear. I think that probably will link back to the next question as well. But I think what is absolutely, or the next panel, I would say, is like, if you train with data, whether it's synthetic data or you have it in your sandbox as a digital twin or wherever you get it from, how do you know you have the right data, in particular to train the exceptions? And how do you prove that you have the right data? I don't know, maybe from UConn perspective, Jacques-Gabriel, do you have anything to say on that?
Yes, on synthetic data, I don't think that UConn will face, because UConn is more or less focusing on human teaming with the automation, so human machine teaming. About synthetic data, I guess that it should be done on step. It's an incremental approach to certification, so synthetic data may come later than you have solved further other problems regarding the automation, how to assess, how to intervene with the human, and so on. And for synthetic data, if you are training also for digital twin, in fact, I was asking to Richard, and I would ask a question to Richard. What about the digital twin? How to trust on digital twin? That is one point of your simulation or your approach. And the other one that I love it about the competencies of the agent. I liked it very much. Which are if you start a discussion on this with your authority?
Richard?
I think you answered it. You got me on questions there. Well done. I think on your first point, what we're doing with regards to synthetic data generation, well, we have invested quite a lot in building probabilistic models. So think about aircraft trajectories, where we're making sure that we have strong probabilistic models so that we can sample all the types of aircraft performance that we can expect, just as one example. So we try and do that. And it's really about knowing what you're not doing in an experimental environment. What are you not capturing within the limits of your predictable models? And so data assimilation and predictability are really important, but knowing what it doesn't do is equally important. To your second question, I didn't quite catch it. I'm sorry, could you?
Yes, the competencies assessment of the agent, because I guess that is a point on the certification track that you want to pursue. Is another approach, no? How to assess the competency of the agent. It's something that you discussed with the certification authorities, framework?
I think that's the competency-based assessment is like our blueprint for the ACO task, and it's early research. We've only been working on the competency-based breakdown and turning those into metrics. It's like recodifying that subjective assessment that's made by instructors and codifying that into something that's useful for machine agents. And in fact, not just for assessment, but actually you might put some of those metrics into the reward functions, and that might create some policies. So no, we haven't been to the regulator yet on that. What we're trying to do is find out what kind of questions we're not asking. So what I alluded to was building trust through competency. And then you've got the competency, which is the capability, predictability. There are other facets of this that we didn't get to talk about, like reliability, responsibleness, and ethics. So that's really just one branch of what we're doing. And there's another 16 branches of that. But the one that's really important for us is air traffic controllers, is building that competency. So we will certainly bring out some of those competency-based frameworks in some journal papers later in the year. So we'll be able to show you kind of some of the guide rails that we're using to try and train agents. Is that?
Thank you, Richard. Let's see if there are any other questions. We still have quite a few minutes. Anyone else looking around? Also at the back. There must be someone. If not, I'll continue with some other questions. But feel free to raise your hand. I think I have a question on the different AI technologies. What I've seen so far, I think in most of the presentations are certainly the earlier research was all centered about machine learning, big data, and then we're just starting to touch upon reinforcement learning, deep reinforcement learning. When I look at the Gartner hype curve, what I notice is that, for example, the large language models are actually at the top of the hype, and they're about to crash again. So is this the right time to start a call for that? Or should we wait until it's more stable? Who has an idea? Romarek.
I mean, the question is, so we have to, I think the performance of the large language model is impressive, and everybody can witness it on his personal usage of large language model, especially with tools such as ChatGPT, but also now you have a lot of sovereign models which are developed, including in Europe. So it's really provide a new capacity for each of us to be more productive. The question is how you can harness this power for critical application on critical processes. So because it's more something that we will use as part of our to improve our operational efficiency. I think there is already a kind of quick win of adoption on some non-critical task. The challenge is the adoption for critical tasks where you want to be sure that your system is not doing any hallucination, for example. But this is something which is coming very strongly. So personally, I mean, I have a lot of examples now which are based on the use of large language model, and we are working on this aspect of ensuring the right level of trust, on making sure we know what we can expect from large language models, so that we don't discover at runtime what are the limitations, for example, whether they do understand logic or not, that we know exactly what is the domain of operation of this large language model before we use them, so that we use them for the right purpose. And this is part of the research we do, but it's evolving extremely rapidly, and it's very interesting.
For us and for now, we are using the LLMs not on critical or safety mission on safety critical application, but more on our production. So the way to help us to write good requirements, to generate a test and test reports, and also analyze the test, and also to write the conformity and the safety documentation. So basically all the technical documentation. So we use it in the software development process and not to provide application to ops colleagues, because for now, and as it is a big black boxes, we don't know and absolutely have no clue on how we can get that through a safety analysis.
Thank you, Benjamin. Unless there are any other questions, I'm going to one of my own. There is one in the back. Yes, go ahead.
Good morning. First of all, thanks for the presentations. My name is Sergi. I'm from Crida. And I was wondering that we were talking about building trust on the models and showing the predictions where come from and all this information, and also was mentioned to integrate models step by step. And I was wondering if showing to the end user additional information about how the models came up with the prediction is going to increment the complexity of or the information that this person has to process. Because if we are trying to deploy models to reduce the complexity, but we are adding complexity from another point, I don't know how it will end up. From what we have seen in previous projects, people like a lot to have these results, but we haven't figured out how the complexity rise. And I don't know if some of you can add a little bit on that.
In my opening picture, it's about building trust. How do you build trust? Do you build it while you are actually in operation, so you get the explanation, or you build it before because you know that it's going to be okay? Camille.
Yes. So in our cases, when we build a machine learning model, we try to find a way to have explainable models. And we actually had some cases where our partners wanted to have explainable features to understand why the model was predicting this or this. And so we made it available. And in the end, they were not using it. So just by looking at the predictions, using it in a regular situation, like maybe daily, having performance assessments, regular report assessments, in the end, they did not need to have all these explainability features. And so we removed them to make it really simple for them to have only just the indicators, and that's it.
You go first, Aurélie.
Yes, hello. Your question is exactly what Trusty aims at providing at least an answer. So we do not try to build trust at all costs. We want to really assess what kind of information, visual information, we should give to the controller so that he trusts the tool. And we actually have envisioned to provide maybe a trust level of the, in our case, the recognition of the image. So maybe something that say it could be a bird or an aircraft with 50% of reliability. We also want to assess by sending false information to the controllers to assess at which point he will not trust anymore the tool. And that clearly is something when I mentioned, maybe you're not familiar with human-centered AI approach, that's clearly incorporating those kind of things, the data visualization interaction, what he can do, can he zoom, for example, the data exploration, how this thing is defined. It also relies to training. So really aims during the experimentation at collecting at least some first answers to that.
Thank you very much. I see looking at the time as well. So we have 1 minute left to round off. Paul still needs to do a few words. Yeah, I saw your hand raised. Is there anything that you want to? It's going to be the last few seconds.
Okay, so I think, yeah, it's a very interesting question. It links back to explainability, not only, but explainability is one way to convey information to the end user. So in fact, you have explainability method, AI explainability methods, which have been developed. It's true that these methods are more used today for development explainability. I mean, this is what EASA, the term used by EASA. So it's more used to improve the confidence for the developer while they develop their systems. But some of these methods can be used also for operational explainability. And I will point at one of them, which is concept-based explanation. Concept-based explanation, it really tells you which concept have been recognized in an image. So if I take the example of the runway detection, it will tell you the concept which have been detected. So not only the pixel which are used, which can be misleading or which are more for development explainability, but also whether you have recognized, especially, maybe I'm not using the right term, but we are calling it the piano, which is the specific mark which you have at the beginning of the runway. So if you are able to detect this concept, then this is the kind of information which you can pass to the pilot, which will increase the confidence because you are capable to detect some of the concepts which are key for the human to detect the runway. And this kind of methods are, at least on our side, we provide explainability methods which are open source in a library which is called Explic. And you can look into this library. Some can be used for development explainability and some for operational explainability.
Thank you very much, Romaric. I think we have to conclude. I see that it's 12:01, so we're 1 minute late. I would like to thank the full panel. I've never had such a big panel ever before in my life. So, and I think it worked quite well. I'm impressed. Thank you very much. Thank you, audience, for listening and for all the questions. From here, I hand over to Paul Bosman.
Okay, so good afternoon it is now, also from my side, and thank you, Ruben, also for the great moderationship. So for those of you who weren't here last year, I'm your master of ceremony. The idea was that I would not be, and Tony would do the job, but he again escaped. So you have to deal with me for today until the end of tomorrow. It is fantastic to see so many of you sitting in the room, and as you may have noted as well in the translation booths. There's not many more that we can cater for here in our meeting room. We have a couple of things for you. First of all, I wanted to reply to a question that I heard as well in terms of availability of data to train models, synthetic data, etc. Just now a small remark that if you Google EUROCONTROL aviation data for research, just Google it, you come to a website where we make available plenty of data sets that you can use for any AI and other R&D purposes, etc. So it's a quite automated process. So this is our little contribution to that debate. We are also, now we're going into the lunch break. The lunch break is 1.5 hours, which is a bit long compared to what we do for other meetings, but that's because we have a fantastic set of stands out there. And if I'm well informed, we're going to see a slide now on the screen, which shows. No, we're not. So, but then you're going to find out for yourself. You come out, you grab lunch, you grab something to drink, and then you spend most of your time, either there it is, please, at the stands. The people all have prepared fantastic demos and presentations for you. Many of the things also come back in the presentations that you see here in the plenary session. So please make all the best use of it. Already, as we saw from the Q&A, there's a lot of sharing of best practices and lessons learned that we can expect from discussions. So I wish you a nice lunch. Just a small remark, there were a lot of people here, a little bit more also than we fully anticipated. So if you're running out of lunch, yeah, which we don't think is going to happen, but imagine that we're running out of lunch, then there's also capabilities and there where you enter the building, we have a small supermarket at -1 where you can also buy some things, etc. If not, I would just say run, and it's survival of the fittest. Yeah, see you all back here in the room at 1:30, and then we're in the safe hands of Guillaume. Voilà. Okay, so really good to see you coming back. Looking at the lunch tables, you've been really kind to each other and allowed for a bit of food for everybody. So thank you for that. Yeah. We swiftly go on with the next section, but not without informing you that apart from this room being really full, as I mentioned already, and you can see it from yourself, we have about 1,000 people online through the streaming. So these people are unable to provide questions because otherwise it will risk to become a bit more too difficult, so to say, for us to handle. But they are seeing and hearing everything that we are discussing here in this room, just that you know. Yeah. With that said, we're going for now to the next session on regulation and standardization. I'm very happy to introduce to you Guillaume. We've been working, what is it, 4 or 5 years ago already together on this topic. And every year there's a good surprise on things moving forward. So really looking forward to this session. Guillaume, the floor is yours.
I'm sorry, I thought I pressed it. So yeah, welcome again to this second session. Glad to have so many people here on site and on the WebEx. We are entering the session number 2, as Paul said, on regulation and standardization. We added the word application because we have also another colleague from Daedalin bringing actually concrete use cases to complement a lot the session that you had this morning. So this morning was focused on research and innovation. We saw from Ruben and from the colleagues a lot of possible applications, very practical, sometimes concrete, sometimes still at the shape of research. Sometimes the underlying technology requests actually even more effort from our side, from the regulatory perspective, to take them on board. And that's very important to achieve this work together. So I have the pleasure today to be supported by a great and exceptional panel of experts in all of the aspects, regulation, standardization, and application of AI. And we are here today to learn from each other and to discuss how we can all contribute to a safer, greener, and more efficient future in aviation with AI. Your thoughts and questions will be very welcome, and we will explore them at the end of all the presentations in a Q&A session. We will take enough time to go for that. Without any notice, so you can see that we have Antoine-Alexandre André from the European Commission, François Triboulet from EASA, Hugo Silva from Daedalin, Patrick Bézombe from Sensenelec, and Anna Guégan as speakers. They will come one after the other to tackle the different aspects, I would say, that are in this title: regulation, standardization, and application, concrete application towards certification. That's extremely important to highlight this message that we are in a very, very concrete deployment of AI. It's coming our way. Actually, I have only 3 slides to perform the introduction, and that's 3 findings that we had very early in the AI roadmap perspective. We saw that it was coming from everywhere, meaning it's all domains of aviation, not only aviation, by the way. If we take the EU AI Act, it's a more wider spectrum. It's an horizontal regulation, but focusing on the aviation domain, we have in airworthiness, in product certification, a number of topics that we discussed this morning. We will see the traffic detection system also from the side of Daedalin. We have in flight training also a lot of usage of AI coming our way. It's actually already used, but it could be used to enhance even further the flight training of pilots, or why not of air traffic controllers. In the ATM domain, you've seen a lot of applications presented already this morning. I focus here as a flagship presentation on the conflict detection and resolution. This is a very nice use case in the sense that a number of people are coming to it with different type of technologies, including in particular reinforcement learning. And it covers the wide spectrum of levels of AI that we have in the AI roadmap, meaning level 1 assistance, level 2 human AI teaming, and level 3 towards more advanced automation. We see in the aerodromes field also the use of AI to enhance the foreign object detection or foreign debris on runways. On the drones and new space side, a lot of anticipation coming in. AI is already powering, for instance, a detection of, let's say, conflicting objects or possibly people, persons on a delivery pad. And the use space is clearly will make a lot of use of AI. And last but not least, on the maintenance side, and it's not the last domain, we could go on and on. Damage detection and the use of computer vision actually is extremely developed there. And talking about the underlying type of application, indeed, computer vision is everywhere. This is the reason why we started the AI roadmap in 2020. It was really the push of deep learning that was bringing us there. But in the meantime, that's why we augmented the roadmap to a version 2.0, as François will present, in order to expand the scope of possible type of applications, in particular for optimization for the type of reasoning systems. And natural language processing is, of course, another type of application. From that, and shared by all these domains and these type of applications, whenever they start to be safety related, that's important to precise, we have a common set of challenges and statement of concerns. Actually, there is a missing, well, okay, it's the formatting that changed. Very clearly, we have 4 types of big concerns. There are many more, but to really sum up what was at the start, data management, knowledge management, difficulty in keeping a comprehensive specifications through data or knowledge, if it's knowledge management. The existing development assurance frameworks are not adapted. That's why we went for this notion of learning assurance process. The AI assurance itself on the system, looking first on the system, addressing model bias, for instance, and variance optimization is a challenge. Elaborating performance guarantees, generalization guarantees, robustness guarantees for models, and we will talk about that a bit more today. The AI explainability is the interface to the human. We talked about it this morning, and it will be also developed in the presentation from Hugo. It is one of the aspects of coping with the limits in predictability, explainability, transparency of models, and AI-based systems. And then the human AI teaming is a real challenge. Here, of course, I stopped at level 2. That's where we are with the concept paper and in the roadmap, but we could go much further if we were developing the level 3 type of challenges. The solution is the AI trustworthiness concept. It's developed in the AI Act. It's developed in the concept paper from EASA and in the standards development that will be presented by Patrick and Anna just after. To give it, and that's my last slide for the intro, to give it a big picture, I took this rule-making concept that we have in the roadmap 2.0 from EASA, but it really factorizes and explains what is the scene. At the top, the EU AI Act will be presented by Antoine Alexandre from the European Commission in a minute. It gives a mandate actually to the aviation. It manages actually horizontally all the sectors, but from an aviation perspective, it gives a mandate through the Article 108 to update the basic regulation, taking into account the high-risk provisions or requirements on high-risk systems embedding AI. This is what we started doing with the concept paper, but definitely we are now entering in a rulemaking with 2 steps that François will describe a bit better. And that's what we will do at EASA level and create also this generic framework of AMCs, acceptable means of compliance, and GM guidance material. That's the next step, the next phase of the AI roadmap, and that's very important for us. And we will do it in adequation and using actually the work already done by our standardization groups. The industry standard consensus standards are already under development from the EUROCAE side, joint with SAE, but also from the CENELEC side. And keeping really this in mind, we need to harmonize, not necessarily harmonize, but at least align our views to understand what is an AI trustworthiness concept from a top-level perspective that is shared across the ecosystem in Europe, not only by the aviation domain. But definitely the rulemaking on aviation will be also to ensure that the certification and oversight system is maintained as it is today, that we don't have like double certification standard for products embedding AI on the aviation side, but still that we stay aligned with the rest of the view. And the whole will be illustrated by Hugo from Daedalin with very concrete use cases that are also under certification process. And this is where, without further notice, I will introduce Antoine Alexandre André, He's a legal policy officer working at the European Commission at DG Connect in the unit that was responsible for the AI policy development and coordination that now turns to be the AI office. He has been closely following the drafting of the Commission proposal on AI, the negotiation process, and the coordinated plan on AI, and he's one of the lead members of the team working on the implementation of the AI Act. So we have the right person to talk about the AI Act and its meaning for aviation. I can note also that Antoine Alexandre has a multidisciplinary background in political science, applied economics, human rights, and internal relations. Before joining the European Commission in 2021, Antoine Alexandre worked as a researcher in applied economics and as a DPO, an information security consultant for the Brussels Capital Region. Thank you, Antoine Alexandre, and the floor is yours.
Good afternoon, and thank you, Guillaume. Thank you, EUROCONTROL, for the invitation to speak the second time in a row. Also, one of my colleagues actually came 2 years ago, so every year we try to update you on the state of play of DI legislation. And this year I come with a strong message, which is we have a legislation on artificial intelligence at European level, which is not yet fully adopted, but which will be adopted, and with content which is already fully finalized. So this year I come with hopefully certain answers. Where I mention only certain answers because now we are entering the implementation phase, so there will still be questions to be answered all along the way, but hopefully the sooner the better. So I was already introduced by Guillaume, but just two additional remarks. So I am part of the service of the Commission, which was in charge of the AI negotiation process, for the AI Act for the last 3 years, becoming now the AI Office, which is one of the governance body for what concerns the implementations of the European rules on AI, but I will mention that in a couple of minutes. So as I just mentioned, we have finally a legislation which is based mostly on what was proposed by the Commission in April 2021, but with certain changes introduced by the co-legislator, notably for what concerns general purpose AI models. But the baseline is still the same. We have a horizontal product safety and risk-based approach in the European AI legislation. This slide is probably a slide that you have seen a couple of times. It's mostly represents the types of or the classifications of risk which has been introduced by the Commission and then supported by the co-legislator in the Artificial Intelligence Act. So the baseline is that AI system that pose a certain risk to health, safety, and fundamental rights needs to be regulated. And for that, the legislature, the Commission initially, then supported by the co-legislator, divided the legislation in 4 categories of risk. First, for what concerns most of the AI systems put on the European internal market, there is minimal or no risk to health, safety, and fundamental rights. And so these AI systems can be used freely on the European internal market. Now, moving one step further, you then have those AI systems with limited risk to health, safety, and fundamental rights. And here we are mostly talking about those kinds of systems which are interacting directly with humans. For these kinds of systems, the co-legislator foresees some sort of transparency requirements for deployers of these AI systems. In sum, if I need to sum it up, the idea is that when a human is interacting with an AI system, it knows actually that he's interacting with a machine and not with another human. Then going one step higher, we enter into the high risk category, which is the core of the legislation. Here we are talking about AI systems that may pose certain risks to health, safety, and fundamental rights, and therefore needs to fulfill certain requirements to be allowed to be put on the European internal market. And then finally, last category are these AI systems that pose an acceptable risk to health, safety, and fundamental rights. Here we are talking about certain AI systems which are so risky that they cannot even be put on the internal market or be used in the European Union. If I now very briefly enter into the different categories, starting from the last one. So these prohibited practice are those practice which are highlighted in the legislation, which cover, for instance, social scoring, individual predictive policing, or biometric categorization. So the idea for these is definitely that after 6 months after the entry into force of the legislation, any of these types of systems won't be able to be used on the internal market anymore in Europe. Then turning to the second category, the high risk category, there are some specificities to determine whether your AI systems is part of this category of risk and then needs to fulfill certain requirements. There are actually two main things that needs to be taken into account. First, these high-risk AI system category covers all of these AI systems that are safety component of a product or an AI system itself, or being an AI system itself, and are covered by union harmonized legislation. And second, these AI systems that are required to go on a third-party conformity assessments. So here, the important thing for all the people in the room and listening to this presentation is that actually aviation is part of this first Annex 1, Section B, meaning that aviation will need to comply with the requirements of these high-risk category. We'll need to comply with the requirements of this horizontal law in the future, meaning 3 years from now, because in the way the different requirements will be implemented, aviation, among other union harmonized legislation, have a certain kind of a transition period, which is extended to 3 years for what concerns Annex 1 product. Then, in addition to this high-risk AI systems, there are also other standalone use cases which are considered high risk if they are used or put into service in the European internal market. And here we are looking at use cases which are covered by Annex 2 of the legislation and which fall into the following 8 areas, including biometrics, critical infrastructure, education, employment, essential private and public services, law enforcement, border management, and finally, administration of justice and democratic process. What does it mean? It means that, for instance, for aviations, when you are doing, for instance, when you are hiring certain people, if you are using an AI systems, it will probably fall into this list, notably because employment has been mentioned in this list of high-risk use cases. But the co-legislator have decided to introduce a very strong but. If an AI system is used to either perform narrow procedural tasks, improve the results of previous human activities, do not influence human decisions, or do purely preparatory tasks, then these AI systems can be considered as opting out of the AI system list. Now, knowing that you are part of this list of high-risk AI systems, what do you need to do? So there are different types of requirements for different types of stakeholders in the legislation. There are requirements directly for providers of these high-risk AI systems, and there are specific requirements for deployer of high-risk AI systems. For provider of high-risk AI systems, there are strong requirements which relates to risk management system, trustworthy AI requirements, conformity assessment, quality management systems, and so on and so forth. For what concerns deployer of high-risk AI systems, there are slightly reduced set of requirements, which are mostly about human oversights and information or transparency for people affected by the high-risk AI systems. Now, in addition to all of this, and notably given the introduction of new types of AI systems on the market, notably in December or in November 2022, the introduction of ChatGPT in the world and the wave of people using these types of systems, the co-legislator have decided to add an additional layer to what was proposed by the Commission, putting some specific requirements and obligations to general purpose AI model providers. So for what concerns general purpose AI model providers, there will be different types of requirements depending on the types of general purpose AI models you are developing. So the co-legislator decided to work with a two-tier approach. A first tier for all the providers of general purpose AI models, which need to have some basic transparency for downstream provider, notably to ensure that downstream provider can comply with the rules of the legislation. Then there are other very, I would say, small requirements concerning a copyright summary of the content used for the training of general purpose AI models. All of this, noting actually that it's quite important that all of these GPI models developed in an open source way will be exempted from these requirements. Then turning very shortly to the highest tier, for those general purpose AI models which are at least 10 to the 25th flops or that are designated directly by the AI office, they will fall into another category of general purpose AI models and will have additional requirements to ensure the protection of health, safety, and fundamental rights. Notably, these requirements dealt with model evaluation, risk assessments and mitigations, incident reporting, cybersecurity, and documentation. Now, as I mentioned, the way the co-legislature decided to move forward with this regulation is in a gradual format. Notably, after 6 months, the prohibited systems or the provision regarding the prohibited systems in the legislation will kick in. Then, after 1 year, the rules on general purpose AI model. Finally, after 2 years, all of the other rules of the legislation will enter into application. All of them except those requirements for high-risk AI systems falling in Annex 1 of the legislation. And here, aviation, again, is part of these exceptions. And so we'll have the opportunity actually to take a bit more time to comply with the requirements of the legislation. And with this, I see that I'm quite ahead, so thanks a lot, and I'm hoping to reply to any of your questions.
Thank you very, very much, Antoine Alexandre. Excellent highlight to see at this top layer that indeed applies also to aviation. So this is one of the entry points into the, let's say, regulatory framework that we are developing at EASA through the rulemaking task that François will develop in a minute. So François joined EUROCONTROL in 2009, and then he was seconded in July 2020 to EASA. So he joined directly the team on the innovation network that I was leading in order to develop the first concept paper, the first issue of the concept paper. And then we turned to an AI program within EASA, and François is a part of the team, dealing actually, is the project lead for AI assurance aspects. Which is very, very important piece of work in the concept paper framework. Based on his ATM and ATFM background, he also represents ATM ANS domain in the EASA AI program. And before being seconded to EASA, François was in charge of the development of the systems for the network manager here at EUROCONTROL. Since 2018, he has been enthusiastic about the possibilities offered by AI and machine learning, and has been at the origin of the NM lab that has delivered successful prototypes for the network manager, as we could see from the colleagues this morning. François contributes to the joint EUROCAE WG114 SAE G34 working group on artificial intelligence. And before joining EUROCONTROL, François worked more than 20 years for the telecommunication industry. Thank you, François.
Thank you very much, Guillaume. And also thank you very much to Antoine Alexandre for setting the scene. Now I think we can move forward on the aviation domain. I would like first to remind you the roadmap 2.0, which in fact was already conceptualized with the roadmap 1.0, published in 2020 or 2019? 2020. So the main phases remain the same. So we are at the moment ending phase 1 of this roadmap, and this phase 1 was really dedicated to exploration. So it was about understanding what is the state of the art, what are the challenges, and what could be the basic objectives to be covered by the applicants when they will come to us with their applications. During this first phase, we issued 2 issues of the concept paper. The first one dealing with level 1, AI/ML, and this level 1 was mainly dedicated to human assistance. In March 2024, we published the second issue of the concept paper, and the second issue addresses the level 2 AI, and we will see later that this level 2 is subdivided into level 2A and level 2B. And this level 2 is mainly addressing the human-machine teaming, the human-machine cooperation or collaboration. We now enter into phase 2 of the roadmap, and during this phase 2, we will establish the set of rules that the applicants will have to comply with when certifying, approving systems embedding artificial intelligence or machine learning. This phase 2 will last approximately 3 to 4 years, so up to 2028. But we already anticipate that there will be a phase 3 with everything that will come at the moment, probably allowing us to still increase the level of automation or even think of some autonomy for the systems. Just a last word on this slide. So it's still the objective that some application will be certified, approved in 2025. I think it is important that we share what is the scope of the roadmap and what are the technologies that we embed into the program. Let's start with this boxes, machine learning and deep learning. These were the focus, as it was mentioned by Guillaume. This was the focus on our work up to now. Data-driven is really what comes first in terms of what we receive from the industry. And this was the scope of the version 1.0 of the roadmap. Now with the 2.0 of the roadmap, we have extended the scope to first logic and knowledge-based approaches, and this is also reflected into the definitions of the AI Act. And also we consider statistical approaches. I would give just examples of optimization methods or search algorithms that could be considered as belonging to artificial intelligence. Very important is a concept that was already mentioned this morning. More and more of the applicants come to us not only with one technology, but they want to mix different of a subset of all these technologies, and this is what is called the hybrid AI. So we consider very important to deal with this hybridation of the solutions. However, there will be some limitations in the first set of rules that will be established. First, in terms of contribution to safety, we consider that we will first go with applications that will have failure contributions below critical and hazardous. And second, no adaptive learning. Only offline learning will be acceptable. To remind you what's in the concept paper issue 2. So first, very important, this is the outcome of a consultation process that took place mainly in 2023. So we published the draft issue 2 in, I think it was February or something like that, for 10 weeks. And from this, we received 900 comments coming from all the different stakeholders from the aviation, be it industry, academia, ANSPs, authorities. So it took a lot of effort on our side to process all these comments, and this is one of the reasons why we could not publish before February? No, March 2024. If we dig into the trustworthiness framework that we have conceptualized and has evolved between the issue 1 and the issue 2 of the concept paper, in fact, there are 4 different building blocks. The one on the left is dealing with what we call the trustworthiness analysis, whereas the 3 blocks on the right depict the technical blocks of the concept paper. For the AI trustworthiness analysis, we start first with a characterization of the application. This characterization aims at the end at classifying the level of AI. And for that, we need a strong ConOps. We need to have the identification of the intended end users, and we need to have what are the high-level goals of the application. From this, we can classify the application, and then we can enter into 3 different assessments. The 2 first assessments are rather traditional. These are the safety assessment and the information security assessment, even if on the day-to-day there will be some adaptations in the AMCs on these assessments. And the last one, the ethics-based assessment, is rather new. For the issue 2 of the concept paper, we continued to consider the ALTAI as the reference, but we really expanded the scope and refined the objectives that were already identified with the issue 1. If we move to the technical blocks, the first block is what I would call it the system-centric view of the approach. So we call it the AI assurance, but in the first issues of the concept paper, it will be mainly the learning assurance. So the learning assurance will be essentially some complementary objectives compared to the traditional development assurance. The AI assurance will also be expanded with the development and post-ops explainability. I think it was mentioned by Romaric also this morning. And finally, it deals also with the data recording. It is really our view that data recording during the operations will be essential in order to measure and to understand exactly how the systems behave when they are in operations. And this will also contribute to the continuous safety assessment. Entering the human factors for AI, this block has been strongly reworked with the issue 2. The operational explainability was already there with the issue 1, but the issue 2 has conceptualized the human AI teaming that comes with the level 2 AI cooperation for level 2A and collaboration for level 2B. But also it is important that we understand and we fix objectives on the modality of interactions between the end user and the machine. The safety risk mitigation block is still a provision. Its objective is mainly to address and mitigate the residual risks that could still be there once the two technical blocks, AI assurance and human factors for AI, remain at the end. So still a provision, but it will come progressively. If we look at the trustworthiness concepts and how we have addressed them progressively, so currently the issue 2 of the concept paper addresses the level 1 AI and the level 2 AI. During the work done on the issue 1, so we have put the bases. So meaning we have introduced the learning assurance, we have dealt with the AI explainability, and we also refine the notion of continuous safety assessment and the security risk assessment. With the issue 2, even if there were already a set of objectives for the ethics-based assessment, it has been really a strong work on our side to refine these objectives. And the strong focus of the level 2 of the issue 2 was really on the human AI teaming. I would repeat again, this level 2A being cooperation, and the level 2A is even more advanced compared to 2A, and it introduces the notion of collaboration between the human and the machine. And of course, the journey will continue from the concept paper's perspective. So we already have identified an issue 3 of the concept paper, and this issue 3 we will address from a technical perspective what has not been addressed so far. So reinforcement learning still being in the data-driven approaches, but we will address symbolic, statistical, and I mentioned already the hybrid AI. Also, as our ambition will be to address the level 3 AI, so this notion of human AI supervision will be addressed, and the unsupervised automation with the level 3B. I would like just to share again this picture that was presented already by Guillaume. Stating that obviously we will rely on the EU AI Act to progress on the rulemaking. So the rulemaking task that has been published with EAPAS is RMT 0742. So it will be our objective to develop the set of regulations that will be necessary for the aviation. Starting with Part AI that will address authority requirements, organizational requirements, and technical requirements. And in parallel of that, we will obviously interface this generic regulation or set of regulations with the domain-specific regulations. Here, I would just provide you with the example of ATM. Obviously, the Part AI will have to interface the 373, but also the new conformity assessment regulations, the 1768 and 69. And obviously, during this journey, we will progressively recognize the standards when they will be established and published. So from the EUROCAE working group, the ED 324 that is still in preparation. So our ambition is clearly to recognize this standard and also to align and to make a strong liaison with the work done by Sensenelec with regards to the horizontal standards dealing, interfacing or answering to the EU AI Act. Okay, time frame, I think we mentioned it. Very important on our side, we do not work in isolation. We have a set of collaborations with the industry, with institutions, via use cases, and these use cases bring us the meat that we need to elaborate on our objectives. And obviously, we are also strongly involved into the work performed by Working Group 114. Not to forget that we are involved and we follow some of the SESAR projects, and also we are engaged, and it will be finished very soon. We are engaged into the MLIP project funded by the Horizon Europe, and this project aims at defining some means of compliance for in support of the rules that will be established. I would just finish with this event that will come soon now. It will be on the 2nd and 3rd of July. It's the EASA AI Days, high-level conference. It will be the second conference of this type, and we really invite you to participate and to register to follow this event. Thank you very much.
Thank you very much, François, for this highlight on the work done on the EASA side by the program. And as you just made the transition on your last slide before the last, actually, the previous one, we are heavily relying on use cases. So that's where it's excellent to have Hugo from Daedalin with us today in order to present concretely what a company can be doing, and again, even under the process of certifying. Hugo is an avionics systems engineer with more than 15 years of experience developing avionics system for civil and military certification. At Daedalin, Hugo works on the certification of AI-based application for situational intelligence in the cockpit. Prior to joining Daedalin, Hugo worked at Pilatus Aircraft as an avionics system engineer for 6 years and served before in the Portuguese Air Force for 7 years in various roles, but primarily as an avionics system engineer as well. So he holds a master's degree in electrical engineering, avionics from the Academia da Força Aérea Portuguesa. Okay, thank you, Hugo. The floor is yours.
Thank you very much, Guillaume, for introduction. As you heard from him, I am not a machine learning expert. I'm an avionics systems engineer, but I hope to show you that machine learning certification is indeed possible and give you our use case of it. So I work at Daedalin. We're a 150 people company of very highly motivated and passionate people about aviation and machine learning. So we looked at how can we support aviation? How can we improve safety? We thought, well, why not use computer vision and neural networks to support general aviation in their roles of traffic avoidance, of looking at outside the cockpit and seeing what is there, how can I fly safer? So with that in mind, we came up with a few applications of our technology. We have visual positioning, where we use a downward-facing camera to figure out a lat-long position based on a pre-established map. This is extremely useful, unfortunately, nowadays with GPS-denied airspaces where we see aviation flying. But then we thought about visual traffic detection, where we put cameras facing forward and sideways, and we train neural networks to detect objects flying and alert the crew if there's a potential collision problem. Same type of architecture can be used to detect runways. We just need to train the neural network to detect a different type of object. In this case, a visual landing guidance can provide ILS-like guidance to an aircraft with a runway that is not supported by any kind of infrastructure. We also have potential applications for unmanned drones or any kind of aircraft that needs to find an emergency landing site and avoid damage to people or other structures. So we look at all of these and we thought, okay, so let's apply for an STC. And we have our project with the PilotEye, which is ongoing, where Avidyne is the applicant with the FAA. And this is a concurrent validation with EASA. Project is going well on its way. It's focused on general aviation Part 23 aircraft, using 3 cameras installed on the wings and in front to have a good field of view of the area in front of us. Then we decided, okay, we need to do something ourselves as well, directly with EASA, as we apply for a design organization approval. And so we came up with the Illumina Vista, which is basically the same architecture, the same type of design, but for Part 27. So in this case, we're the applicant with EASA, and we're also doing a concurrent validation with the FAA for this, because we want to make sure that the authorities are moving in the same way together. And this is, like I said, same type of approach. We're just using a camera pod with 3 cameras and the same computing platform, just a different display than the PilotEye. So these projects, both of them rely on the same traffic detection technology. And it's basically the cameras capture high resolution images, 6 frames per second. We apply some pre-processing to the images, we crop them into smaller sizes, and we pass them through a convolutional neural network. Now, this neural network is going to be able to detect if there is an object or not in there. But as you know, the prediction of the detection performance of a neural network on a single frame is quite small. So we need to apply other types of post-processing to the result of the neural network, which is going to increase the performance of the system overall and provide a good traffic detection situational awareness system to the pilot. So where is this? So we started quite some time ago with the CODAN reports with EASA. We've done a project with the FAA for a visual landing system, and we're basing our certification means of compliance with the first usable guidance that was released, as you heard from Francois quite some time ago. We have issue paper and CREEs accepted for the PilotEye project, and we're going to use the special conditions released by EASA for the Illumina Vista. We are well on our way to certify these projects, and we are fully confident on being able to do so. As you've heard extensively in the morning and before as well by Francois, the first usable guidance relies on the trustworthiness concept, and it has different building blocks to it. So I want to take some time to talk about one of these building blocks, explainability for development and post-ops explainability. So we have a very high parametric input space. If you think of the outside world, the different combinations of aircraft flying, of different backgrounds, weather events, changes over time, it is just very, very high complex, and it is impossible to capture every single type of image that's going to be input into our system. So one of the key aspects is to properly categorize and characterize the operational domain. So that's the work that goes into the ODD from the first usable guidance. And here I give you just an example of how we established the different operating parameters that affect the performance of our system. So we've mapped them out, and this allows us to have a good relationship between them, understand how they affect the performance of our system, and have a clear idea of the corner cases that may appear. And this then gives us into the objectives of data completeness and data representativeness. So we fly around a lot, we gather data from our users of our experimental systems, and we use all of these images annotated by humans to train our systems. Then we need to make sure that these data sets represent the real scenarios that the aircrafts are using our system are going to fly in. But it is, of course, impossible to expect that the data sets are going to be completely covering the entire possibilities that we can get. And this is where other things like what we've heard in the beginning of using synthetic data, of using different statistical analysis, that is going to come in to make sure that what we have is enough and complete without covering completely the input space. So data recording, this is another objective that is key to the post-ops explainability. It is the certification objectives to support the monitoring of systems in operation and to support accident or incident investigations. But it is also very key, as we all know in the industry working in AI, data is the king. We need data to create new systems that behave better, that perform better, and can do more functions. So it is in everyone's interest that this data recording system works properly. Now, we don't have, as an avionics supplier, we can't rely on a good infrastructure of servers, of collecting data. So it is very important that we understand that we need to record data that is enough to troubleshoot the system, to reconstruct what happened, what led to that event, but also the data we record cannot have bias. So we need to make sure that the requirements that go into our data recording system account for that. Now, continuous safety monitoring, this is based on the data recording that we do. And we need to evaluate what keeps happening once the system is operational. What happens if when we characterized the operational domain, we made mistakes? What happens if now there's quadcopters flying around that are in a much more higher density than before? So these things are going to change the performance of our system, and we need to monitor for this. It is key, and frankly, we've done this from the early days of our company. Our data management plan, our data recording system, our data flow is all built to account for this. I'll give you just one example of this. Our early days of the traffic detection system was made using R44 mostly as the object to be tracked. And as you can see, it has a very clear triangular shape that the system in the early days was detecting traffic cones because it had the same system, the same shape. So these types of things, and this was, of course, early days and the clear ability to resolve this, but it is key during operation that we prepare our systems and our processes to account for these types of things. So thank you very much for time being here. It was an honor. Thank you.
Thank you, Hugo, for this indeed demonstration of the practicality also of applying the guidance. And we have numerous, I would say, applicants bringing us different use cases, and that's the beauty of it. Let's say to test the guidance even before we enter in rulemaking. We enter now, so we have already a test bench in live with the first application projects. And as you mentioned, we didn't say it before. We have a special condition that was published in order to raise the part of the concept paper, I would say, requirements in order to ensure the first certifications. So I call now Patrick Bézombe, who is graduate from the École Nationale Supérieure de Technique Avancée, ENSTA, Paris Tech, specializing in perception systems and robotics. Patrick spent most of his career in aeronautics, electronics, and sensor systems. In 2009, he was appointed as technical director for the sensors and guidance navigation system within the French Defense Procurement Agency. In 2018, as deputy director of the French Doctrine Center, he published the concept of use of AI in defense and initiated the setup of the Committee on Ethics for Defense. Patrick is the vice chair of the Sensenelec GTC 21, which is the committee dealing with the EC standardization request on AI. So he's also the head of the French delegation at ISO IEC SC 42. So thanks, Patrick, for being here to talk about the standardization of the AI Act in a horizontal manner, I would say. Thank you. Thank you very much, Guillaume. So I have 7 minutes and we're already late, I believe. So I'm going to be in a fly mode. Let's get started. So where are we now in the horizontal standards development? So luckily we started quite some time ago, more than 1 year ago. We have a couple of things going on. I will get back to that later. Right now, the target is to deliver standards in Q2, maybe Q3. We'll see what, if this is achievable. We are still expecting a revised standardization request from the European Commission just after the AI Act publication. So I don't have the target date for this revised standardization request, but it will most likely confirm the first standardization request that we received in May 2023. Okay, so request for standardization, nothing really new here. We've got 10 requirements. Ranging from risk management to conformity assessment with key issues like transparency, human oversight, accuracy, robustness, cybersecurity, quality management systems. It is well understood by everybody that this is going to be a horizontal approach. This has been mentioned many times by the European Commission. And so we have to provide requirements at the horizontal level. So this is quite a challenge because we have many verticals, if I may say, and we have to find the proper requirements and to give some flexibility while giving some flexibilities to the different sectors. Okay, so I'm not going to deep dive in our standardization work program, which is very consistent. So basically, JTC 21 is going to rely on ISO ACI and specifically on SC42 standards. First, for terminology. So we have two key standards, 22989 and 23053, for those who are used to these concepts, standards. There are other terms in other standards as well. And then we have key standards on specific concepts, controllability, transparency, robustness. Those are being developed. Some other concepts are also being developed, like human oversight, but this standard specifically will arrive too late. It has really to be noted that JTC 21 is not bound to SC42. We can, of course, adopt their standards as is, but we also can modify those standards. And we clearly envision to modify some standards because the philosophy in SC42 is not to develop standards for regulatory purpose. It's to develop standards for the industry. Within JTC 21, we have this other mission, which is to support the regulation. So we have to, in some cases, to modify ISO AC standards to fit the European Commission request. We're developing, we have planned to develop at least 4 main standards. The first one, the AI trustworthiness framework. I will get back to this one after. Another one on AI risk management. There is 2 other that are being considered. The one on AI quality management system and another one on AI conformity assessment. On the AI trustworthiness framework, well, the working draft is planned for September. It is fully designed to support the AI Act. It should be an entry door to the AI standardization. It shall include some high-level requirements covering every aspect of the standardization request. And worth noting it will include a chapter for sectoral application because one size doesn't fit all. We are fully aware that it may happen that some horizontal standardization doesn't exactly fit some sector. So we will address that concern in the this standard. And I think that it could be seen as similar in spirit to the EASA concept paper. I mean, overarching approach, high level on, I think some parallel in vision, in approach, and that's a very good thing. We still have to work together with EASA to make sure that the terminologies and the concept are aligned. So what is needed now is better cooperation, more cooperation between JTC.1 verticals. I have to admit that I'm not seeing that enough. The health sector is very much involved, but beyond the health sector, we're missing some key sectoral contributions. And this is essential because we want to ensure consistencies between the different visions, and we have to avoid as much as possible those potential inconsistencies. And I think I'm right on time. Thank you. Thank you, Patrick. Perfect timing indeed. We are not too late. I think just 2 minutes, so we will make it. And to complete the view on the standardization aspect, so I'm calling Anna Guégan from EUROCAE. She's a senior technical program manager at EUROCAE since 2018. Before, she worked on satellite regulation and ICT market access in London consultancy and for the French embassy in China. She has a bachelor in Chinese studies from INALCO and a master in political science from VU Amsterdam. Also, she owns a CISSP security certificate, cybersecurity certification, and an AREC radio license. Anna, the floor is yours. Thank you.
Thank you. So, good afternoon, and thank you, EUROCONTROL and EASA for inviting us. I think you hear me better like this. So I'm going to present working group 114 activity. So I don't know if you're familiar much with the EUROCAE. We are a standard developing organization for aviation. And we bring together all type of stakeholders, the manufacturer, service provider, international organizations such as EUROCONTROL or IATA, CANSO, as well as the regulators, EASA, and together we draft standards and through our process that are quite robust, including an open consultation for formal standard, we try to build the best standard possible. So talking about EUROCAE Working Group 114, it focuses on the establishment of common standards to support the development of certification approval of aeronautical products based on AI technology. The scope is airborne and ATM ANS domains, crewed and uncrewed aircraft. And very often we represent it as a little house, as you see on my slide. With at the top there is the leadership. That's the leadership on SAE and EUROCAE side with the co-chairs and the secretary. Actually, at the side of where I was seated, there is my co-chair, Fatih Kakai. So if you have technical questions, please, he'll be better suited to answer them. And as well as the secretary of SAE and EUROCAE, so in the leadership. Then in the executive committee, we also integrate all the subgroup leads because the way the working group is structured is in a number of subgroup, as well as EASA and FAA to ensure that we're really aligned to what's really needed. So you see at the bottom of the little house picture, all the many expert organizations that's supporting this effort. So the first publication we had was ER 022, the Statement of Concern, published back in 2021. And at the moment, we're still working on ER 27, which is very advanced, but need to find the final approval. And that we intend to publish this in the coming months. So that's the taxonomy in artificial intelligence. Also later this year and or early next year, we'll have the use case consideration ER and the ED 324, the process standard for development and certification approval of aeronautical products and implementing AI. It should be published by in the early next year, but in the meantime, in the coming later this year, you should be able to look at it when it will be in open consultation, because in our process, open consultation is really open to anyone in the public. And I didn't insist it so much, but for us, it's really important that our standards are developed also jointly with the US. So in many cases, and we work a lot with RTCA, but in the case of artificial intelligence, since the beginning, the working group worked hand in hand with G34 from SAE. So this ED 324. So to build this standard, we first identify the concerns, capture regulatory requirements, and define the scope of standard. Then it was to define the strategy to integrate the new standard in the aviation ecosystem. Then to build an end-to-end view, define high-level desired properties, define engineering process with objective and activities, and then define a modulation of the standard objectives according to criteria. So now I see I have only 2 and something minutes left to speak. So I'm going to go very quickly on the roadmap. The important thing is that we've been really from the beginning working hand in hand with EASA, and as much as possible made sure to support as we could with by developing standards. So the kickoff meeting was in 2019. During the phase 1, we had our first statement of concern in 2021, still in phase 1. And now, as EASA is getting to phase 2, we intend to publish the taxonomy document, the use case consideration, and most importantly, the first process standard publication, who hopefully would meet the need of EASA. So to put it back in the ecosystem of EUROCAE, so we have a number of standards in the other working groups, such as in working group 63, we had the ED 79B and ED 135A. So at the system level, so airborne aircraft and airborne system and safety assessment that were published in December. And at the item level, we have ED 12C, joined with RTCA DO 178C. The airborne system software, then ED 109A, ED 80, the airborne hardware that we are actually going to possibly reopen. We are opening a working group on this, but then we'll see what to do next with the ED 80 and ED 153 ground safety assurance. And ED 324 is precisely in between all of at the model level for between this system and item level. And by this, we hope we can address the need from EASA. So to conclude, what's really important for us is collaboration. So that's collaboration first within a working group and between our working group, as well as to work together internationally with SAE, that's what we do, but also to work with other international organizations, such as, for instance, in the previous panels, there was a lot of all the R&D, and I think in many cases we involve or we can be used as resource for SESAR program and other R&D, because it's important to be for a standard to be at the right time. So thank you.
So that brings you perfect on time to our Q&A session. So I hope you enjoyed the different presentations. As you could see, it's really complementary to what you saw this morning. It's really bringing also the scene of regulation, standardization, also application/certification. So now opening the floor to anyone having questions, burning questions, please. Please, Thomas.
Yes, thank you very much, Thomas Buchanan from Skyguide. I would like to thank all the speakers for the discussions we had, but in French, you say, je reste sur ma faim. There are one or two elements I'm still looking for. We're talking about systems, we're talking about standards and regulations for the systems. We're not talking about reversion back to human if the system should fail. So where do we stand on that? How is this whole context human-centric? How do we balance what the machine does, what the human should still do? And I know there's a session tomorrow about the teaming between human and AI, so maybe that's where my answer will be. Thank you.
All sessions will be complementary. Let's say we could take the question, but maybe I will turn to you, Antoine Alexandre, first to put the perspective again from the top, and I might complement with François on the EASA perspective.
Yes, thank you. Thanks for your question. I think it raised an important point, which is the human in the loop, which is one of the requirements of the Act. So the legislator is quite clear on that side. There should be all the decision taken in the end by a human. Now, the way the human will take over I would say the elements which have been provided by the AI system is subject to the standardization notably, but also to further guidance from the legislator. So this is definitely a question which will be discussed in standardization, how to ensure humans stay in the loop and how it can actually, how we can make sure that the human is the ultimate, individual to take the lead on AI systems.
Thank you, Antoine Alexandre. I don't know, François, if you want to take it, or I can take it from yes, exactly from an EASA perspective. Just to complement, and we are fully aligned with the logic and the philosophy developed in the AI Act. Definitely, that's our driving factor. But in essence, we are asking ourselves. We've completed the concept paper as François presented up to level 2. Until level 2, there is definitely a human in the loop, and actually really in the loop in the sense that this person is in the operations. We allow ourselves to go a bit proactively with the level 2B to a capacity to give a certain authority to the AI-based systems or system of systems in order to open the possibility for certain applications or certain type of operation that our industry is bringing to us. After, it needs to be translated into reality through certifications, definitely. Yet, in this case, the human is still capable of overriding anything happening, and of course, overseeing. The oversight is one of the functions developed in the Article 14 of the AI Act very, very clearly. Where we will be a bit more in an investigation benchmarking mode, I would say, is entering, as François developed, in the level 3 guidance in the issue 3 of the concept paper. Because there we talk about level 3 as supervision. So here we still have a human in the loop. However, that's a place where we have to see this gradation, let's say, of delegation of authority, if I may use the word delegation, which might not be the final one. We need to ask ourselves how let's say, how much it makes sense first from an operational perspective. So still human-centric, human-centered. We want to keep the human at the center of all considerations, but definitely the ambition is more to open the door to specific operations, in particular for the drones type of domain, maybe urban air mobility or advanced or innovative air mobility, if we take it from the large spectrum. So in order to anticipate that, we need to see how far the barriers can be pushed, but still considering a human capable of still taking over in case of an alerting, for instance, because that's the definition we give to a 3A. And where the question mark is big and completely largely open for now is on the level 3B, which is the high end, I would say, of what we call advanced automation. We don't even talk about autonomy. It's another point of discussion we may have, but we're not even talking about autonomy. We imagine that certain operations might be extremely automated to the point that there is no need or capability for a human, in fact, to oversee those type of operations. I'm thinking U-Space in particular, but that might not be the only case. And we have to see, and here it's not the AI roadmap or the AI Act actually pushing, it's more in parallel another roadmap, which is how far can we go in innovative air mobility or in U-Space, etc. So we will accompany a trend, I would say, and see where are the boundaries. And if those boundaries are acceptable from an AI Act perspective, then definitely we will push them in a safe mode, in a secure mode, in a sustainable mode, of course, very, very carefully with the human in mind, even if the human is maybe not in the loop anymore. And that's really the ambition for the next step. We are not there yet. Patrick, you wanted to complement, please.
Yes, first of all, thank you for this question, because indeed this is very important. I would like to mention that in JTC 21, in the AI Trustworthiness Framework, a project that I mentioned before, we tried to touch on this key topic. We identified things like human oversight architecture, allocation of function, and so on. And there is one thing that we are discussing right now, which is the term human in the loop, because actually there might be more than one human and more than one loop. So it's a human in the loops. I don't know. This concept doesn't reflect the full complexity of what is human oversight. It's not an easy task, actually.
Indeed. Thank you. And Hugo, you had also a contribution?
Yes, I just wanted to say, to give the example of what we are doing, which is a level 1 application, I understand, but basically the way we consider that is by looking at the failure cases, doing the functional hazard analysis, applying SSAs, and considering what happens if our system fails, what types of alerts are given to the human, and what will the crew do with that, how it will behave. So this is well in our consideration as a system designer. But I would also like to point out, automation in aviation has grown exponentially from the early days, and failures of those systems have always been taken into account. We currently, without AI being considered, we have full automation for an aircraft to land completely without the human intervening. So it is not, it is a challenge to consider what happens with the AI, because we don't always, or we need to fully understand what decisions are being made and why. But it is not a challenge that we, as a part of the industry, believe it's unsurmountable.
Thank you for the compliment, Hugo. It's another perspective, but I would say we still have to consider that, yes, if you can land an aircraft fully automatically, you still have a human in the loop for a very good reason. So we have to really carefully evaluate this safety element that the human is bringing before jumping another fence, I would say. And that's, again, in line with the AI Act, which is another consideration to keep in mind. Any other question from the floor? Yes, please.
Thank you. Vincent Lambercy, Fox ATM. Part of our tasks involved analyzing incidents with classical system, not AI-based. And my question goes more to the technical experts, because we said to make the system trustable, to better understand what they are doing, we need data recording. Completely agree on that. That's something we do in ATM already. But what kind of data recording are we speaking about here? Are we only speaking about recording the input and the output, which is probably technically feasible? But I imagine you cannot record the status of a neural network at every point in time, because I imagine that's too much data, not being an expert. So what kind of recording do we need from a regulatory and technical analysis perspective?
Maybe Hugo, you can start, and François, you can complement. Yeah, if you want.
Yes, that's a very good question. And like I alluded to during my presentation, it's going to depend heavily on the system that you're developing, its function and architecture as well. We know that our system, when given one frame, will always provide the same result always giving that initial frame. So we need to understand it very well, and we do not believe that we always need the internal state of the CNN, but we do need to understand what has led to that event, and that's going to depend on the application that you're doing, and it's going to be up to the machine learning experts, to the systems engineers, but also to the authorities to agree that the data set, that the requirements for the data recording system are appropriate for that application.
In the issue 2 of the concept paper, we have identified first the different use case for the data recording. One of them being the incident and accident investigation. Another one being the continuous safety assessment, and the third one being understanding how the system behaves really in the operation, so that if it deviates from the intended function, this can be understood, and the system can be retrained. On top of that, we have identified the basic monitoring that needs to be put in place, and obviously this monitoring will need to be recorded. And among these monitoring, there is the ODD. So we expect that the data being provided to the system stays within what was the defined ODD. It does not mean that we will ask the provider to record, the applicant to record all the images which are given as an input to the system, but probably extract the parameters that Hugo presented during his presentation, and record these parameters, so that any deviation from the expected behavior can be monitored and recorded. Another one is the performance of the system. So if the AI system or the AI constituent behaves with a certain level of degradation compared to the expected the performance that was tested during the system development or the constituent development, this has to be recorded, and this will contribute to any post-analysis on these records. So I think we have already some ideas of what will need to be recorded, but obviously this will need also to be considered in the future, and with the understanding that the story will not be the same for the avionics and for the ATM domain, where we have memory and computing power.
Thank you very much, Hugo and François, for this answer. I saw another hand raised on that side, and then I will turn around because the people behind don't get the chance. Please, yes, go ahead.
Yes, Julien Chapuis from NavBlue. So first, thank you for the update on the regulation. I'm quite glad to see it is progressing, because I think probably today a lot of companies are restraining themselves until we get a clear regulation, because don't want to develop something that's not going to be certified. By extension, when we talk about this certification, and particularly third-party assessment, which is already something that is always quite heavy, let's imagine that in a company we are developing a product that would be considered high risk, but that does not itself use AI. But in the development process, we see with the development of LLM that this become really a commonplace to use that in our daily work. Let's imagine if I extrapolate, I have a developer that will use Mistral to code and will make mistakes in his algorithm and is developing a high-risk system. I will have the product owner using a tool like that to summarize the regulation and make false interpretation on the regulation. So we could see all kinds of failure modes coming in from these other aspects. So what would be the philosophy in terms of regulation of a system like that? I mean, are we going to try to regulate and to assess these systems that by themselves might be commercial elements like Copilot or stuff like that? Or do we rely, for instance, just on the existing quality process? Do we need to update these?
Yeah, it's an excellent question. Maybe I will start and give the floor to Antoine Alexandre to complement. What you could see in the presentation from François on the other side is really we try to comprehensively define the conditions under which and its different dimensions. And one dimension is the criticality of the application. Another dimension is the type of usage of AI, level 1, level 2, level 3, etc. And based on this canvas and maybe other parameters we will see, but from a rulemaking perspective, we say this triggers the need to have a certain AI trustworthiness framework put on this application. So it means, does it exclude or not? Because that's the point you're making, the tools used to develop trustworthy AI. That's another point where we need to, as we have to do it for certain domains of aviation, like maintenance, for instance, they don't have traditionally a safety assessment in place, so they will not know what is the criticality of the application from that perspective, and they will rely today on calibration, qualification of tools. So in that domain, we will have to consider what is the safety-related usage of AI. And based on that, then we can see if the organization, and if it applies to the organization, and possibly the tools that are used in order to develop. And it has to be, again, proportionate to the usage. That's very clearly the case. And that will be, let's say, found out through the rulemaking activities, element by element. So first on the embedded systems, embedded doesn't mean flying or airworthy, but in the embedded systems, definitely the safety-related notion is pretty easy to define. For tools used in order to develop AI, that's another piece of cake. And as you said, tools used to develop systems that are not AI, we have really to make a clear boundary and distinction between those different cases. So that will be really part of the organizational aspects or organization requirements. I mean, on a DOA, for instance, on a POA, on a MOA, on the different organizations that are approved, depending on the type of usage. Now, if the tool is used in a non-safety related manner, I guess it will escape the high risk and AI trustworthiness framework. But that's again, the way we see it for now. We have not yet done the rulemaking. And that's why, to complement, I turn to Antoine Alexandre. Maybe he has an even more precise view than we have at this stage. Thank you.
Thanks for the question. Yes, I mean, I fully agree with you, Guillaume. So there is really an important point, which is that the legislation mostly covered, or what we consider the high-risk AI systems, are mostly a safety component of products. So if an AI system is used to, I don't know, to develop, for instance, part of a system overall, and it's not directly a safety component of that system, then it's not covered by the legislation. So actually, you know, using Copilot, even if it's for deploying what could potentially be considered a high-risk system, but not AI then, but a high-risk system, is not then falling under the legislation directly. I hope this clarifies a bit.
Yes, thank you.
Yeah, you're welcome. I will turn around just in case there is a question from my back here. No? So any other question from the floor? Yes, please.
It's a big discussion.
It
Not
is
an easy discussion. About the human, which the gentleman spoke, I think we are seeing the current situation, but this technology progresses very fast. So in the future, as we discussed with some French colleagues before, with artificial intelligence deployed everywhere, the knowledge of the other generations which are coming after us, we will have a kind of knowledge and suggest, if we can say so, will be minimized. So when the systems are going to put down for any reason, these communities of experts, it's very difficult to communicate and to put the systems on board. Apart from that, the question is to the Commission, to Antoine, why the ETSI, why ETSI is not participating to the standards you are using. It's in its position, it's sense and elect. Usually there is also a common contribution. And you are speaking for safety without speaking for the security issues, which EASA, of course, is handling a lot of this. But when you have certificates, you know, artificial intelligence and general digital societies, they have a cybersecurity thing, which ENISA makes the certification. So your certificates are going to be complied with ENISA's. Do you have any kind of communication with them? Thank you very much.
Thank you for the question. So I give the floor directly to you, Antoine, and then I will have to close the forum.
Yes.
Thank you.
Thanks for these questions. Actually, I need to clarify then what I said, and also I think what Patrick said, because it's not fully true. In the standardization request, actually the role of ETSI is mentioned. The standardization request itself is given to SEN and SENELEC and indirectly to SEN and SENELEC JTC 21, but there is also recognition of the work which has been developed at ETSI level, and there is actually in the standardization request a requirement actually for SEN SENELEC to get in touch and to coordinate with ETSI, notably on those standards which relates to cybersecurity. So that's perhaps for the first question. Then for what concerns cybersecurity or security in general and the role of ENISA, first I want to also clarify that we are actually on a weekly basis in contact with ENISA. We know what they are doing, and actually we are also trying to coordinate our input in JTC 21 and in other standardization organization. Maybe one clarification is that in the AI Act, and this is sometimes misunderstood, in the AI Act, actually for all of these systems which do not fall directly under union harmonized legislation, so not aviation, but for other types of high-risk AI systems, there is a possibility for self-certification, meaning that there is no need of a third party to certify that a system is complying with the rules, notably, following for a company standardization, adopting standards which are recognized by the European Commission is sufficient. But here again, it's falling outside of the scope of aviation, which is one of these types of union harmonized legislation, which already needs to undergo a third-party conformity assessment process.
Thank you very much, Antoine Alexandre. I see the time has elapsed, so thank you very much for the questions. Thanks very much to all the panelists for the precious presentations and answers brought. You can find all of us at the common stand. It's the first one on the right-hand side. Maybe the slide will come on the screen. And you will find us if you want to carry on or if you have more burning questions. I think the takeaway is step by step, we are moving towards alignment, harmonization of all this framework, but within at least the aviation sector, you could see it's step by step in terms of deploying the type of AI, deploying also the technology, not going too fast, too far, and taking into account safety, security, and sustainability as a driving factor. Thank you very much for your attention.
Thank you very much, everybody. Thank you very much, Guillaume. I think we had a very good state-of-the-art presentation on these different policy standardization topics, etc. We're going to break now, and after the break, I hope you'll come back for a slightly more pragmatic set of applications, etc. There are about 20 stands to be visited. I want to see a show of hands. Who has visited 5 or more of them? Uh-oh. So get your cup of coffee and then visit the stands. See you in 45 minutes. Okay, 15:45. And in order to keep the good momentum built up so far, we will continue the sessions. This time now the session number 3, improving the ATM network performance with artificial intelligence. You're going to see a bit more practical cases. You're going to get some demos. And so without further ado, I suggest that we start. And the first presenter is going to be Emilien Robert from EUROCONTROL.
Good afternoon. Thank you. Good afternoon. My name is Emilien Robert. I'm from EUROCONTROL, and today I will talk about what we do in AI in CNS. And the first question you may have is, where do we use AI? Well, we're not very originate on this one. Usually to find AI, you need to follow the data. And for CNS, it's the same thing. We are doing AI where we have data, which is within the CNS monitoring function. We have a mandate from the European Commission to monitor the European infrastructure, the CNS European infrastructure. And to do that, we are collecting data from various ways. We have a ground monitoring network of ground stations. We are doing monitoring flights, on which we record a lot of data. We are gathering data from INSPs, but also from specific CNS data providers. And all in all, we are gathering around terabytes of data per day. So it's quite important. Of course, when you talk about big data, big depends on who is talking to. But for us, terabytes per day is quite big. We are gathering all of this data, and then the data is used to support different use cases on CNS. It's all about analyzing and monitoring the activity. We are using report, dashboard. We are providing data to our internal and external stakeholders, and we are providing support on all of these use cases. And on top of this monitoring, we are trying to improve the way we do monitoring by using AI. We have a number of projects that have been developed over the years. Some are still exploratory, we are still working on it. Others are completed and have been deployed in the past few years. We're still moving on with the different projects. Now, the second question that we may have is, what do we use AI for? Why are you using AI on all of this data? Well, the first reason is to automate what we are doing, either the data processing or the detection of outliers. And I will go from different examples. Third example I have for you today is this ionosphere monitoring. So we detect and characterize specific ionosphere structure, potentially impacting GBAS. And to do that, we are collecting data from a lot of monitoring stations over Europe. You can see on the left-hand side the plot with the different clusters of data, doing some data processing, identifying this structure that we are looking for, and then we are applying manual validation to ensure that what we are detecting is correct. And when we are doing this manual validation, we found that actually 92% of what was detected by the tools was measurement artifact. And this is where we added an AI module on it based on a neural network, and where we are able to improve the detection of a specific structure by a factor of 2, reducing the manual validation by a factor of 2 as well. Same activity, different domain, data link. We are interested in detecting and characterizing the Delmo 2 burst collisions. So basically, when two aircraft or two ground stations are talking at the same time, the messages are colliding within each other, and we want to assess the magnitude of this phenomena. To do that, we are doing flight monitoring, and then we processing the data. And again, we used to do that manually to count the number of collisions over subsamples of the data. And based on what we are doing, we are able to process around 2% of the data collected. Now that we have developed an AI model, also based on a neural network, we can process all of the data with an accuracy of 98%. Another example of what we do as automation is to detect the outliers. Again, it's the same for as the previous example, it's on data link. We are using a lot of data link messages, and then we are classifying these messages using a Markov models, and then sub-classifying using K-mean clustering in different groups. And by doing that, we can detect which sequence of messages is actually does make sense, on which sequence of messages seems a bit bizarre or different or unexpected. And with different sequence of messages are sort out as outliers. And by doing that, we can further assess, analyze what's going on. With this model, we were able to reduce the analysis times from hours to minutes in finding patterns and anomalies. So it is really an efficient way of working. The second reason why we're using AI is to improve the data quality, the data completeness, but also creating more data. Other example to show, again, back to ionosphere. As I said before, we are able to improve a way to monitor the ionosphere by a factor of 2, but we will still have some margin for improvement. And this is what we're trying to do now, is to further increase this ratio. And what we discover that in the actual data, there is a lot of noise of jump. So what we are doing is that we are using clean data. We add artificially some noise and jump. We're using an encoder decoder to recover the initial signals. And then we are applying this encoder decoder to the actual signals. We may have some data quality issues. And as you can see on these slides, it's a bit tricky, but the original signals are the blue and the black. And you can see a lot of noise, a lot of jumps. And the after signals are the magenta and yellow. And you see it's much more smoother. The noise has been removed, the jump has been removed. And by doing that, we can improve data quality before it's being classified. Another example of completing data sets is what we do for surveillance. So we are monitoring the modest radar over Europe. To do that, we have a network of ground receivers which are collecting the data. However, due to the protocol of communication between aircraft and radars, when we collect the data from the aircraft, we don't know to which the aircraft is talking to, and we don't know what the aircraft is saying. We are just collecting bits of messages. So we developed two projects. One project is what we call reply allocation to understand who the aircraft is talking to. And for that, we are using an order linear regression based on the fact that the radar antenna is moving, is rotating. And we are able to allocate some of the reply to the radars and then to compute KPIs for the different radars. And the second project that is now completed was to answer the question, what is the aircraft saying? For that, we used natural language processing. We consider the message of bits as a sentence. We cut that in different words, add some tokenization, add some properties to it, run a LSTM on top of it, and then we're able to fully decode the data for investigations. Another example is what we are trying to do with this DME load assessment, which is a work in progress. Basically, we can measure the loads over DME in Belgium. We have a traffic over DME as well. And the question is how to better understand how the aircraft are selecting the DMEs and tuning the DMEs. For that, we are using a graph neural network. It is still work in progress, so I don't really have performance to announce yet today, but we have a poster outside, so if you're interested, we can give more details later on. Last reason for using AI is to classify trajectories. For that, we have two projects. One is on drones classifications. So we are collecting drones trajectories around airport, on some airport in Europe. And we define different five classes of trajectories based on operational aspects. You can have a hover class, for example, where the drone is going up very quickly and then going back again. Or the monitoring class, where the drone is actually checking a specific area. These two different classes may have different impacts for aviation. And using a neural network, we are able to classify these different classes. Last example is approach and landing trajectories. We are trying to identify possible inefficiency along the trajectories. For that, for each and every runway, we can clusterize the trajectories using the scan, then estimate a reference path, and then we can compute the deviation to this reference path, filter on that, and try to identify holding patterns or other source of inefficiency in the flight path. This is also a project which is just starting, so I don't really have performance. It's just an ongoing investigation. And then last question, now that we know what we're using the AI for, is how do we use AI? What technique are you using? And actually, we're using a highly customized techniques to each and every project, and finding the most promising approach is our biggest challenge. So if I put on the left side what data we have, and on the right side the applications, the question is how do we link the both? So we can have different kind of data. We can have a labeled database, we can have unlabeled database, we can have an environment, and we can have just not enough data. But moving to the AI family is quite easy. If you have a label database, you will go for supervised machine learning. If you don't have a label, you will need unsupervised learning. For an environment, you can do reinforcements. And if you simply don't have enough data, you are what we call frugal AI. We mentioned that this morning for efficiency. In our case, it's just that sometimes we don't have enough data. And you have to complement the lack of information by other means. The tricky part is then to move from this AI family to the applications. We're using a wide range of technologies where we've been used neural network, where we've been used language processing technique, encoder, decoder, regressions, Markov model, DB scan, and so on and so forth. But finding the right techniques for the right project to the right data is really not easy, and that's our biggest challenge that we have today. I will now conclude the talk with a map of the lobby. If you want more information, we have a big stands outside. You just need to go outside Europa, grab some food, and then turn right, take a drink, turn left, cross the lobby. We are on the right-hand side. Thank you so much for your attention. If you have any questions, please.
Thank you, Emilia. I think he also sells second-hand cars to anybody interested. No, thank you. Very good presentation. As the CNS activities are a bit closer to my heart, we are really happy with all the different AI techniques that we are starting to apply, where we're receiving gigabytes of data every day, and this is really a way forward to find the real issues in the European infrastructure. With that said, let's move to the next presenter. And we are leaving the comfort zone of Europe, and we're going to Shevin, who is from NAV Canada. Shevin, the floor is yours.
Is this on? Good to go. Okay. Cool. Well, I'm really happy to be here. I talk very fast. I'm also very excited about the topic, so hopefully you can keep up. My name is Shevin Fernando, and I'm the manager of Advanced Analytics and Artificial Intelligence at NAV Canada. Yeah, I'm here to talk to you all about digital twin cycle performance optimizer. So SBO is our first digital twin at NAV Canada. We started the journey in 2019 with a proof of concept in 2020. Yeah, 2019, and then 2021, we actually started full product development on the tool. So it's been a real journey, a real battle. The product is in a really good spot right now, and I'm here just representing my team, who's done an excellent job getting to the product to where it is based on the use case. So it is a virtual assistant that supports our sector optimization and shift allocation for our operational users in Toronto right now. And a bit of background about NAV, so you just know we have 18 million square kilometers of airspace to manage and control. So we're in one FIR right now, Flight Information Region, and we'll be going to the second one in June with full national deployment by the end of next year. I was about to say November, but my boss is here and that's not realistic. I'm going to say March 25. So why am I here? So we'll talk about some of the key challenges, what SBO is, what it does for us, and how it's being used in the operation. In terms of key challenges, I think just listening to everyone talk today, these are key themes across service providers and navigation service providers, et cetera. For us, we know the future is digital. We are moving towards an operating model that is digital. We're in a hybrid space right now where some of it's analog, some of it's digital, and SBO and digital twin capabilities has really helped us think out how we want to actually go towards that digital mindset. Our data platforms are fundamental. You mentioned in your presentation, Hugo, right? Great presentation on how critical data is for and thinking about data before you actually build a system. And that's what SBO has really helped us do as well, thinking about how we want a data structured, how we want to use it for operational use, and how we want to get the information to the hands of the people who need it. And that's proactive decision making, right? We want to make sure that our tools, our products go to our people who need the information when they need it, where they need it, and on time and accurate. So SBO has really helped us kind of move towards that space and proactive decision making. In terms of what it is, so it's a virtual representation of NAV Canada's airspace, and it's not necessarily your traditional digital twin where you see the airspace and all that stuff moving out. We've moved this and pivoted this towards more of a dashboard visualization of what's actually happening in our airspace and what is going to happen in our airspace in the next 6 to 36 hours, essentially. It's a cloud-based application developed in Azure. We're using our operational data sources to pull in all the information. We have some simulation in there, so what-if analysis, machine learning algorithms, which I'll talk about shortly, and then we have analysis in there as well, post-op recommendation. SBO is in sync with the physical world, so data is always streaming from our applications in real time, and we actually batch process it and produce results twice daily for our users' needs right there. That's a image of what it looks like. If you come to the stand 10, I'll actually go through it with you. I won't go through this whole thing, otherwise I'll be here for the 8 minutes I have left. So in terms of how it works, so we've really positioned this tool multiple different ways throughout the last 3 years. And we work with our users to position this tool where they understand what the purpose of this tool actually is for them, right? So it may be a digital twin of our airspace, but for our users, it's a digital assistant to help them with their sector optimization and shift allocation for planning for a better today and tomorrow, right? They don't necessarily, they care about the technology, but they want to know why do you have this and why am I supposed to use it and what does it do for me, right? So the product mindset approach really helps us when we think about implementation of AI tools in the operation. And I should preface by saying this is a decision support tool, not necessarily a tool that's in the operation, like on the seat sit next to the controller. It's back behind the scenes with our unit managers. So data streams in. We have a flight prediction component that generates a probable outcome for tomorrow. Uses like gradient boosting around classifiers. We have tasseled algorithms in there. So those tasseled algorithms essentially take those flight trajectories that we've just predicted and runs through a set of and subset of algorithms to figure out, when are the handoffs happening, what conflicts are going to be happening in the airspace, et cetera. So really workload of the air traffic controller. From there, we look to optimize sectorization based on the flight prediction and then task load. Because if you have 10 flights in an airspace, those 10 flights may be very simple to handle. But if you have two flights with high levels of complexity, high levels of diversity of tasks, that actually means your task load for 2 flights is more than your task load for 10 flights. So we're trying to combine those two concepts together to look at the sector optimization for the day. And we're using dynamic programming, their shortest path algorithms for that. And that goes into shift allocation, which is the proposed optimal coverage for the day. And that's based on everything I just talked about, plus any parameters and business rules that our workforce planning teams, our operational teams are mandated to build in. So for example, in Canada, the controllers can't be on the glass for more than 67% of their shifts. So we make sure that constraint is put into our algorithm as well. So we don't actually predict something that's not feasible or realistic for the controller to actually implement. So that's how it works in terms of the ML components. I won't go through this all in detail. We can talk about the stand, but I would say the 2 critical components are the things on the left-hand side, or at least my screen, the data engineering and the feature engineering. Data is the key thing to this entire thing. Without the models, or without the data, we don't have any models. And we spent a lot of effort to build up our pipelines, build up our cloud data platform with the right data, with the right features, right invitation, all that stuff to make sure that those count models, the flight route model and the flight schedule model are actually accurate and usable for our predictions. We combine all those models into a post-processing step, which is essentially fuzzy logic, which generates where the schedule is going to be for the next 30 hours in advance. This is all regulated and mandated by our MLOps infrastructure. So we have model performance monitoring and degradation, which I'll also talk about later in my slides. And that's all automated, essentially all automated. So that's the ML behind the scenes that's working. In terms of how it's being used in the operation right now, so deployed in November 23, we did some training, well, not some training, did a lot of training, and we started using it. We got more feedback, and we've actually redeveloped some of our algorithms over the last 3 or 4 months to enhance the product based on the feedback. So our users will use this daily planning session essentially with our ops duty managers and ATC supervisors, where they'll look at the recommendations. They look at other things we don't consider in SBO right now, like real-time weather, for example, any constraints in the airspace, route deviations coming up from the FAA, things we don't necessarily capture because there are a million variables in our airspace, as you all know. And then from there, they'll figure out what the strategic day will look like or what the plan will look like for the optimal sectorization and the shift coverage to improve our service delivery. We also have use cases right now around post-ops capabilities. So our users want to look at what was planned, what was predicted, and what actually happened to help them understand their long-term decision-making around the operation and really be more strategic and be proactive in our decision-making. So we don't necessarily be too reactive all the time, right? So over time, you like to see your predictions, your planned and your actual start to, come to the middle around how you look at your sectorization and your optimization for our shifts. In terms of how it's performing, so, lots of lessons learned and, listening to everyone talk about it today, there are, definitely parallels everywhere. But for us, representation was very important and trust was very important. And how do we get there? Technical deep dives with our users. I seriously didn't think I'd have to go and sit and talk about the 48 variables that go into, or features that go into our count model. But the question got asked, and we went and showed them these are the 48 variables that you want to see. And our controllers want to know that, or unit managers want to know that. They're not going to remember it potentially, but at least they know, understand what we've done to actually build those models so they can start to trust it, right? And then you start to feed them more simple information where they can actually, understand what's happening and is it accurate, et cetera, et cetera. So those technical deep dives really helped us. And then we just continually have a product user mindset that is people focused. So listening to their feedback, listening to their suggestions on predictions, on task verification, things like that, right? So making sure that a handoff is a handoff in our algorithm in terms of what's actually happening in the real world too. And that goes into trust. So we really have partnered up with our operations teams to deliver this. So they've been on this with us since the ground floor, and they've done an excellent job bearing with us through some of the technical details and actually implementing those technical details to reflect their reality. And that's really helped us with that partnership mentality to build that trust up with the operation. And for us in Canada, we have 7 FIRs. I love to work virtual. It's sometimes much easier for me not to have to go to the office, but in person in the air control centers, going to each unit and spending the time with the people and developing those people relationships has really helped provide us with the quality, representation, and trust of our tool. And it's been honestly really fun to see the controllers get really excited about these types of tools and technologies that can help them. And we really want to focus on addressing their challenges, not necessarily addressing the funnest algorithm to implement or the coolest thing to develop or going to the next level with LLMs, things like that. We want to make sure that the machine learning we produce actually delivers a result for our operational users, and they can actually understand what we've done. And so far, so good. In terms of how we actually provide that trust is around monitoring systems and degradation. So for us, we have MLOps fully embedded into our software development lifecycle. We also follow DevSecOps as well from a product perspective, software perspective. So MLOps really helps us look at monitoring performance at inference on a daily basis, twice daily actually on all 4 of our models. And then we look at our daily flight counts and hourly predictions. And right now our range is between 85 to 95%. It is over 95%, but I didn't want to put 100% in there, so I said 95. It goes up to 98, 99. We don't want to brag too much, So 85 to 95%, and we feed that information back to our users as well, right? Because they want to know that. And we actually set the degradation threshold with them. We didn't just make it up and said we're going to do it 85%. They said, we have enough information. We trust the tool that with 15% of inaccurate results or no results, we still feel confident we can make decisions because the whole point of this tool is to marry up their expert judgment and opinion with more information, more data points, right? So from a failure perspective, if SBO didn't exist today, our controllers would do an excellent job with their sectorization and shift allocation, right? They still have the ability to do that, and they will still keep the ability to do that. This tool just gives them more information to make those decisions a bit more holistically than what they're doing today. And from a degradation perspective, it's all automated. That's the best part. When we first started this, it was really difficult to monitor algorithms, maintain the algorithms, do all that work, and also develop the product as we went through. So once we got MLOps automated, our algorithms will look at, we have champion challenger concept in there. So essentially the challenger, if you're under 85%, the challenger will spin up, retrain the entire process. And if it beats that champion that's in right now, it'll promote itself all the way up through dev, QA to prod. And then it stops just before prod actually, because we have mandatory things to do for audit that we have to do manually. The machine can't do that. So my team will take care of that stuff. But the challenger concept really helps us understand where the algorithms are at. And if we actually need to go back and do more work on the algorithm side, if it doesn't beat that 85%, right? Because there's drift and things like that we don't address with our models. So that's the degradation part. Where you can find us, stand 10. I don't have a really fancy map with telling you where to get the drink and all that stuff, but hopefully you can figure it out. Stand 10. We have 2 demos, SPO, and then the second demo we have is a proof of concept. Really fun proof of concept. It's an anytime, anywhere simulator that we've essentially built using AI, gamification, and simulation to provide our students with learning opportunities in ATS learning, because that's another big pain point for our organization is to make sure we have the staff that we can train and help our ACOs be successful. Thank you very much for listening to me.
Thank you.
So this morning we learned in the presentation from Romerick that after 4 years, a human being has 50 times more data than any LLM could ever capture. I'm sure, Seven, you did this after a year already with the speed that you talk. Anyway, I think your slide with the trust quality monitoring degradation lessons learned, etc. I think that's something we all can really relate to. Very good to see this here presented together, and really something that for everybody to take at heart when you're starting to roll out your application. I think there was a lot of value in there. The next presentation is on another very interesting topic, on speech to text and some things around that. And for that we have Alessandro. Now, Alessandro has been in a heavy fight. And he told me that the guys he was beating all in hospital, I'm not sure they're gonna get out, and he just survived with a small injury at his wrist. Yeah, so grateful to have him here, to have him on the good side of the story. And Alessandro, the floor is yours.
Thank you for your presentation. Hello everyone, I am Alessandro Longobardi, data scientist at TINAV, Italian Air Navigation Space Service Provider. I am pleased to be here to discuss the significant progress that TINAV is making in the field of artificial intelligence in ATM context. In particular, we talk about STORY, a tool designed to simplify safety investigation processes, which make use of AI solutions. In STORY, we integrated artificial intelligence to support the analysis of safety events, ensuring compliance with European regulation. The main objective of this tool is to simplify the daily task of transcribing the voice between conversation to the pilot and ATCs, which make this task easier is automatic speech recognition and artificial intelligence processes that automatically transcribe human speech. Currently, tasks like this are only done manually, consuming time and resources. ISR optimizing transcription processes, ensuring accuracy, efficiency, and boosting safety. With the project like STORY, we are addressing short-term operational never need with using ISR solution. To develop an effective automatic speech recognition system for ATM context, we need to adopt ASR model inside the ATM context, and given the highly specialized language employed, full of unique terminology, acquiring pertinent data inside this context is proved challenging. And to address this need, we select different sources, include this dataset from open source projects such as ATC2 and internal EUNAB resources, all in strict compliance with GDPR regulation. This dataset consists of audio recording and reference transcription. Here, a complete overview of the STORY workflow. We start with acquiring a raw audio file without any additional information. The audio file is submitted to ASR custom model that implemented as encoder-decoder transformer network to transform network to generate the baseline transcription. Next, the system performs speech diarization, which identifies and separates the different voices within conversation. This is a crucial task to distinguish between the voice of pilot and controllers. Successfully, the text transcription are subject to data harmonization, which data harmonization that incorporating transcription rules such as ECAO alphabet, ECAO airline codes, and contextual use of number and punctuation. Finally, the system uses text classification to define the role of the speaker in the conversation based on the semantics nature of the text. The final result is a draft of conversation, which controller can review and edit as necessary before proceeding to the generation of the final document. This allows human control over the transcription. Furthermore, the final result can be sent to underlying pipeline to contribute to model retraining processes. This is ensuring a progressive improvement on its transcription performance. Here, a quick look to historic current performance and the time saving they provide respect to traditional transcriber method. For example, for a file of 30 minutes, it takes less than 3 minutes to produce a baseline draft of transcription, to which must be added a overhead of checking and eventually edit the various segments of the transcription. Therefore, together with the ATCs, we estimated that all of these halves a gain of about 60% in terms of workload, of traditional workload. While to evaluate the accuracy of our speech recognition model within the complex domain of air traffic control, we leverage the word error rate matrix, which measures the discrepancy between the automatically transcribed text and the referent text. And in the context of ATC communication, where clarity and accuracy are essentially for safety, it helps us to ensure optimal performance and reliability. The graph shows the evolution of the word error rate over the word error rate score percentage over time. And actually, we achieve with our model a score of 6% on our validation set. On the left, you can see the first two ACC in Italy, where we start the experimental phase. Here is a video demonstration illustrating a real use case of the story web application, developed entirely by our innovation team, based on the operational div of in-app ATCs in safety events. First, the user selects the audio file they wish to transcribe. Don't know the reason.
Tower, pekné popoludne, Tatra 613, establish LS31.
Tatra 613, dobré popoludne, Štefánik, Tower, runway 31, clear to land, wind 300 degrees 19 knots, maximum 33 knots.
Runway 31, clear to land, Tatra 613.
And after landing, vacate via Delta.
After landing via Delta 613.
Yes, we also select the crucial information associated to safety event. Once the preprocessing phase is complete, users are presented an interface that allows to
Tatra 613, dobré popoludne, Štefánik, Tower, runway 31, clear to land, wind 300 degrees 19 knots, maximum 33 knots.
Correct any error in transcription or identification of speaker, and the start timestamp. This is the result of the speech realization. Finally, the editing phase, you can generate easily a final document that contains all the transcribing segment, ensuring a complete and accurate result of the audio transcription process. Looking ahead, the story will move forward with several key objectives. We'll be expanding the dataset to include the scenario behind en route cases, fine-tune the model to improve the where score, enhancing the UX and UI design aspect, integrate story into NAV ATM system. Here, an overview of the other NAV AI projects, spanning from SESAR initiatives to the effort of the Innovation Lab, all with the same aim of advancing air traffic management through the latest AI-based technology. Thank you for our attention, and if you have further detail about our stand, you can come there. Thank you.
Thank you very much. As I think we already mentioned last year as well, also from EUROCONTROL, we are very interested in this speech-to-text development. We've been playing with some models ourselves. We are very keen to coordinate with any other player in the KTM community that is looking into this. It's very promising to see the results, including the fantastic Italian accents that are well decoded. So thank you again, Alessandro, for that. Then the next presenter, and he's so keen that he's already there, is Dirk Zinken from the Deutsche Wetterdienst. He's going into yet another field of predictions together with us. Dirk, the floor is yours.
Thank you. Yeah, my name is Dirk Zinken. I'm working for Deutsche Wetterdienst. I want to present our AI-based tool for predicting runway in use, based on or utilizing self-enforcing networks and our DWD's ICON D2, D2 ensemble prediction numerical weather forecast data. The project was conducted with University Duisburg-Essen and the RIBASC research enterprise and Deutsche Wetterdienst, of course. So necessity for tailored weather information for AATC purposes has increased during the last years. For operation at international airports, actual weather is an important decisive factor. The information on wind, temperature, wind speed, visibility, significant weather is measured in meter and predicted in TAF forecasts, which are quite well known. But for respecting the wind, it's only a forecast on ground level, so 10 meters above runway, well, what is not really sufficient. So the selection of runway in use is one of the main decisive factors on an airport, and changing the runway decision on a later stage is always has an effect on the network and operations at the airport. So what we numerical weather prediction data always has quality issues, probably because deterministic models, in deterministic models, forecast errors could not be well quantified. So forecast errors depend on quality of the initial conditions, quality of the border conditions, and also of the internal model physics. The solution for that is ensemble prediction forecast models, where a deterministic model is run several times with slight variations of internal model physics, initial conditions, and the boundary conditions. So ICON D2 generates 20 members through a variation of these parameters. And so the result is more or less 20 more or less different weather forecasts of wind and other conditions. The self-enforcing networks is a specialized neural network, which is based on a semantic matrix, which is containing some kind of prototypes. We call it reference types of weather situations, which have to be learned by the neural networks. And according to a learning rule, the weight values between the connections between attribute and object are generated. It's worth to note that these weight values are not generated by random as in other neural networks. It's based on learning rule and the semantic matrix, which is in the trained and in the ready to use self-enforcing network is some kind of fix. To get the activation output, we use the relative activation function, which you can take from the slide. The input data is numerical weather predictions on an area approximately 100 by 100 kilometers around Frankfurt with a 2-kilometer resolution, resulting in 50 by 50 grid points. Two met parameters, the northwest wind and the eastwest wind, which is orthogonal wind vectors for each forecast point. We use the lowest 37 model levels, and we have 20 ensemble members. That generates a sum of 3.7 million input vectors per time step, and we have 37 time step per ICON D2 model run. So 8 model runs per day, up to 36 hours ahead. One challenge in creating the system was the selection of the reference types, which are incorporated in the self-enforcing networks. We had a giant pool of weather situations labeled with the runway in use at that time. So what we did was to implement a regulator algorithm, RGA, which is some extension of a genetic algorithm, which grabs some situation of a pool, checks how they perform with the model, and then throw out some of the situations, take on others, and finally we got a set of some of these situations representing either the one or the other direction of operating in Frankfurt, which performed quite good. These were included as a prototypical weather situations which had to be learned by the model. So we have a use case. It's a runway change that was performed at March 10th at 7:45 UTC. It was a runway change from runway 07 to runway 25. So what we see on the right side is the dots which are not connected. That's the reference types. So we have several reference types for runway 07 and only 2 in the upper right for the runway 25. And what we see is the trajectory of the forecast through these model. That's a connected line. The green dots are representing the runway 07 as a selection of the model of that time, and the blue dots the runway 25. So you can see the change is predicted between 16 and 1700, and that's a situation at about 30 hours ahead of this, before that change. If you step through the upcoming model runs, every 3 hours we have another model run. You can see that it's quite stable, always between 1700 and 1900 or 1700, or in this case 1600 or 1700 on at about 6 hours or 5 to 6 hours before that actual change. So we also the explainable AI aspect is always, as we heard several times today, very important. So we also incorporated some elements of explainable AI in the model. That's one of the ensemble members, green, some kind of heat map. The green colored pixels are supporting the decision of the model at this time. If it's colored like this, red, that ensemble member is opposing. There could be mixed situations as here in the southern part it's supporting the decision, and northern part it's opposing. So that's an overview over all 20 ensemble members from the forecast at 1600 runway 27. So everything is supporting. That's in that next step. 1 hour later, the model performed the change, and you see some variations. Not all of the ensemble members are supporting this, but the overall decision was to change the runway, and that's in the upcoming hours. It's similar changes. We also have a 3-dimensional visualization of the feature importance. So that's the situation at 1500, some hours before the change. In that case, all the ensemble members are included in one graphic, but you see the spatial distribution of the support or opposing the decision to that. That's 1 hour later. You see a slight change, especially from the southwest approaching. There are some small red dots, which is opposing the situation and signaling that there is a change coming on. 1 hour later, that's where the model has changed the direction now to runway 25, and see, especially in the southwestern part, in the lower levels, at the grid points, there's a good support for the change, but probably an aircraft approaching from the east on runway on operating direction 25 probably has experience in some other conditions in the approach, but at the landing in the low levels, it's the right decision on that, and that on stepping further, it's going more clear that that's probably the right decision. Yes, quality of the prediction model. We tested the model with randomly selected samples of archive data. Cases of runway 07 and runway 25 were equally distributed. And for runway 07, we got 99% precision and 95% of recall. Interestingly, runway 25 was the other way around. We had 95% of precision and 99% of recall. The overall performance of the model is 97% precision and recall. And next step will be that it is available for further evaluation for Frankfurt after summer break. And we are planning to expand the forecast for other airports, especially in Germany, in 2025, depending on resources and priority. And I want to invite for further questions and discussions, and probably having a closer look to the visualizations at our stand in the Europa lobby. And for further contacts, don't hesitate to contact me or one of my co-authors. Thank you very much for listening.
Thank you, Dirk, and all your colleagues for this very interesting presentation. It's one of these topics that we see regularly coming back over the last couple of years, etc. It's impressive to see the accuracy improving. Any meteo forecast that can guarantee us a 97% accuracy, we buy immediately. So if it's now AI, then we start to still have some little doubts, etc. And what can we do with this operation, etc. But again, very impressive to see the results. And let's see how further we can bring this activity into the European ATM. With that said, we now go to the last presenter, which is Katalin Sergiu from Frequentis, and he's going to talk about a topic that, again, I think we've seen before, and it's about the topic we love and or hate very much, which are NOTAMs. If only. Okay, let's stop there. Katalin, the floor is yours. I'm really looking forward to the presentation.
Thank you. Thank you for the introduction. So today I will speak about Notam Wingman project, which is an AI-driven optimization for operational Notam management. My name is Sergiu Cristea. I'm a technical project manager within Frequentis, and my focus area is aeronautical information management. Some of the projects that me and my team are working on, I will mention briefly. The first one is European AAS database for EUROCONTROL, which contains not only aeronautical information from the European ANSPs, but also aeronautical information from all the other ANSPs around the world, making it the largest database with aeronautical information in the world. Another project that we focus is the flight plan optimization system built for Qantas Airways, which is based on an IXM51 database. Some of the achievements of this project is we managed to reduce the fuel burn and the CO2 emissions by at least 2 to 4% on average, both on short hauls and long hauls, as stated by Qantas. It was a key enabler for non-stop commercial flights from Australia to Europe, namely Sydney to London, so-called Project Sunrise. And Qantas call it Project Sunrise because actually you see the sun rising twice while being in the same plane. This project is in operation since 2018, and it was made possible by aggregating multiple sources of data. Besides static data, also digital Notam, commercial, other types of Notam like local Notams from Australia. The project won a Jane's Award for Technology in 2019 and is one of the drivers of developing the internal product called Notam Wingman within Frequentis. Let's start with the challenge. The challenge was to analyze all the data queue that they had, and we quickly realized that there are an astonishing 1,500 Notams being corrected per day due to poor quality of the data within the Notam. This was the starting point of an internal research, and we started looking at all these Notams. So we quickly realized that within the Notam, there is field type Q in which you have a certain format. In the lower part of the slides, you see that we have an FAR, we have a Notam code, which is standardized by 5 letters of numbers. You have a traffic purpose scope, also which have standard ICAO values, and then lower and upper limit and coordinates and the radius. Some of these data were not even mentioned. Some of these data were wrongly mentioned. So we started analyzing how can we improve this system. Obviously, the source of information, it is in type E field, which is a plain English language based on ICAO acronyms, but it's entered by the operator, so it needs to be interpreted. Let's see how we managed to do that. I have an example to present you. For example, we have an initial Notam, and you can see here the type Q. It's filled in, but it has no coordinates in there. By parsing the information in type E field, we could identify the fact that it's mentioned there, a designator, Lev, we have a feature type, in this case a takan, and we have an action which is unserviceable. Based on this information, which is parsed using the AI algorithm, we are able to query the database in such a way that we can identify the feature, in this case a takan with the designator Lev, and we can actually extract the coordinates of this feature. And ultimately, we have a corrected Notam or a corrected proposal Notam in which we introduce also the coordinates of this feature, and then we propose it as a corrected Notam. Further, I would like to present you a demo of similar examples, how we have it in the product itself. I hope it will work. Okay. First Notam that we have here, it's actually a correct Notam. It has all the fields populated. So we run it through the corrector. Basically, nothing is changed because the system identifies that the data is correct and it does not need to change anything. I have another example right here where you can see that in field Q, the traffic purpose and scope fields are not filled in at all. By applying the corrector, the system identifies the missing value based on the item E, and then it proposes with a confidence level of up 99 to 95%, and also identifies that is a DME, and it queries the database to retrieve the coordinates, and it updates also the coordinates in case they are not corrected. Let's try another example. This time we have a route as well. Item Q, it's populated, but it can be optimized. We run it through the corrector, and the corrector proposes an enhanced item Q as well as the coordinates which are retrieved from the database are published there, and you can see the confidence level also in the low bottom right part. The last example that I will show, it's a danger area, for example. Again, the item Q was not filled in at all. So when running through the correction, it identifies the FIR, it identifies the type of the Notam and all the fields which weren't populated, and also the feature, and extracts the coordinates of that feature and populates it in the corrected Notam that we provide for the proposal. Now, how this is happening? We started by having a Notam database which contains both the initial Notams, so the wrong Notams, and the corrected Notams. And we feed them into a classifier training. So what is this classifier training? It is an algorithm in which we know the initial Notams and the corrected Notams as right input data. And we started to parse the item E. Now, item E, as I mentioned, it's a plain English text that needs to be understood what is in there. We started to parsing in order to format it, in order to extract the information, as I mentioned before, like identifying if there are coordinates in there, what type of features, what type of action is. And we do this through a pre-classification phase in order to train the model. So the model then it's able to output so-called multiple output classification. Why multiple output? Because we need to provide all the fields in type Q field, like traffic purpose code, Notam code, all at the same time. So once this this algorithm is learned, then when a new Notam comes, obviously it's run through a validation with some business rules, standard business rules in the provided by ICAO, and then you have a decision. If the Notam is correct, then it goes on the lower part, and the Notam is directly published. If the validation fails, that we propose to go through the correction system in such a way that we do the same kind of steps. We parse the item E field, we identify the actions which are mentioned there. We pre-classify those actions, and based on the training which was initially trained, we propose the traffic purpose scope and Notam code correction. Also, we query the database, the ES database, in order to validate and check the coordinates of the identified feature within this action. So we propose the coordinates that we have in the system, which we know are correct. This results in a proposed corrected Notam, which is run again through the same validation rules in order to validate that the proposal is correct. And then we have another decision point. If the Notam has a higher confidence, like you've seen in my video earlier, then we publish directly the Notam. If the confidence that the system is providing is low, then it goes to a manual review and correction by an operator. Quick takeaways about how to use an AI system in enhancing Notam. Obviously, in AI, everything is about data. So data analytics, you need to have them. With the available data that we had, we use like 90% of the data to train the system. We use 5% of the data to optimize the system, and we use 5% of the data to test the system in order to ensure that it has a correct understanding of the data. Then, obviously, this data needs to be pre-processed and encoded in item E. That means eliminating the dots, eliminating the end words in order to extract the meaningful information from the system. The next step is identifying the right architecture model of AI, because out of the existing ones, we could identify a complex algorithm that is being trained, especially in this domain. And then obviously you get in the loop of optimizing the parameters and improving the model. At the end, we introduce it into a live application that basically saves a lot of time from the operator that validates this Notam in order to have correct data in the system. And with this, I thank you very much, and I'm waiting questions.
Thank you very much, Katalin. And this was yet another very good presentation with a practical use case around use of AI for the ATM community in Europe. You have to note as well that also in our NM Ops room, we are receiving equally hundreds, if not thousands, of these Notam. Our usage is slightly different in the sense that we need to see if there's a regulation in there that needs to translate then into some limitations around capacity, demand, etc. The AI application that we developed, and I'm sure that Benjamin, who is not sitting here at the moment anymore, but he will be at the stand, is the one that we just prioritize these thousands of email or Notams in the right way. We still deal with them, all of them, every day, but we take what the AI application thinks is the most important one at first instance, so that we can react more quickly, etc. But again, this use case for the wider EAD is really interesting to use as well. Okay, I really must compliment the speakers. In the preparations that we had last week, we told them we have 12 minutes per presentation, and it has been scarily precise in its execution. So this is really, really a big achievement. Thank you very much. This means that it's now over to you for some questions on any of the very cool presentations that we had in the last hour. Anyone that I can give the floor to? Yes, please, there at the back. Max.
Thanks, Paul. It's Max Bazzina from Ingenov. A quick question, last in, first out for Katalin and Frequentis. Have you considered working on a Notam generator based on AI?
Yes, we have considered this, and it's in the future roadmap.
Any further follow-up? Are you interested, or are you? What's your use case?
Well, the use case is, yes, we've seen a demo of correction. Likewise, I could see a use case of having a kind of a generator starting from very basic information that do not require to actually put the format oneself, and therefore increasing efficiency and reducing the amount of errors that we make from putting things in format, which is one of the human weaknesses that we generally.
Yeah. Let's also not forget that through the CP1 regulation, we're now moving in Europe to the digital Notam, so that hopefully will create a bit more systematic structure to everything, and we're moving more and more into SWIM, where we're moving to information services and less of these horrible messages that we keep on throwing at each other. But please, Catherine.
Just to complement my answer, my very short answer previously. Yes, we see a couple of use cases like I presented right now. One of the use cases is saving time of the operator that corrects the Notam. But you are very right. What if the Notam would be correct from the very beginning? So such a system can be implemented directly at the operator that introduced the Notam in such a way that guides basically or trains the operator to write a correct code from the very beginning, so you don't have to spend time in correcting something which was wrong.
Thank you. Any other questions? You're not going to get drinks before 5 o'clock, eh? So yes, please.
Thank you. Question to both Frequentis and Enav. You mentioned in the case of Frequentis that field E is plain English, but we all know that Notams are far from plain English. First, it's all caps. It's full of abbreviations that are sometimes very complicated, and the same thing applies to VHF transmissions. It's on one side standardized, but on the other side has a lot of words that are not covered by, let's say, commercial models, think Siri, Alexa, all those kind of models. So the question is, how much effort was it to train your models to understand aviation English or Notam English in that case, and how far your models are from standard models?
I have to admit, it wasn't easy. So it was quite an effort to train the model because, like you mentioned, it's well, plain English, it means it can be understood by a human, but it has a lot of acronyms. So we had to really train the model with the acronyms that we identify there. We had to create a vocabulary and rank this vocabulary in such a way that it understands what specific action the operator wanted to present in this Notam. So it was not an easy path to train the model.
Alessandro, do you want to comment from your side?
Yes, from my side, with our data that we have, we need to address this problem. But for related to specific acronym, it is not a concern the model, because this is a special rules. We apply the rule after the pre-processing of the pipeline.
Okay, thank you very much. Anybody else that would like to come in? Scanning the room. We're not getting tired, are we? Yes, please.
Hi, Robin Weiss from DFS Germany. Just a quick thing, because we had the big block about explainability and regulation, standardization, but now we have also heard a lot about confidence levels, and even with you, Sergio, also the decision about the confidence level to give the Notam directly or give manual validation. And just out of interest, I would ask, I mean, the word confidence of a model implies a strong human interpretation, but as we still, even with good explainability efforts, we still do not exactly use what the neurons in the model exactly learn in any case. So how far are we with being really confident about our confidence level of the model? And is it also a discussion within the standardization team, for example, to give a threshold? I mean, what do we take 95%? Do we take 90%?
Thank you for the question. It's quite a good one. We had this question before internally. And what is the threshold that is accepted in order to feel confident that the data which is published by the AI, it's the right one? We take quite a conservative approach here with a quite high value right now, and based on the fact that we will have new data and we will train the system more and more and more, because it's about training the system in order to increase the accuracy. The system right now was trained with available data, with available Notams. That confidence level will increase, so we can decrease this threshold. Yes, we have this threshold to 90-something%. I would not say it, because it's basically a convention, so we can change it. It's how much data you have to train the system in order to increase this confidence.
Thank you. Any follow-on or any other questions? Yes, please, Hugo.
Yes, I would like just to add to the answer, basically the question from our side when certifying the system. We face this exact same question. We're trying to perform a human task. So how well does the human perform this task? And that is not an easy question to answer, even to understand how well does the human perform. We sort of assume that the human performs well, but we all know humans make mistakes constantly. So this is an ongoing effort to try and quantify this. But I keep coming back to this. Avionics systems, as an example, the ones I know of, they are not 100% correct. They don't work deterministically always all the time. Traffic detection systems, for example, suffer from geometry coverage, where if the aircraft that is looking for the other one is on a certain orientation with the other one, we may have RF blockage issues. So when looking at this, we need to understand that sometimes the confidence level is not 100% for non-AI systems as well. And that's part of the shift, I guess.
Indeed. Thank you. Anyone else who would like to come in on this? Be careful, even if you just scratch your head, I already give you the floor. So anyone wanting to come in? No? Start to call it a day. Has been pretty intense. 3 sessions with a very good overview of what the last year brought us in terms of evolutions in the research and innovation, the regulation and standardization aspects, as well as the applications. I mean, if you compare this to just a year ago, the applications that we just saw are a significant step forward. The digital twin concept is really maturing, giving us real tangible benefits. And I keep on speaking slowly just to see. No, we're done. Yeah. So then I think we're going to make a conclusion for, first of all, this session. So thank you again for the different speakers. Yep. Don't hesitate to go and visit their respective stands where they can provide you much more detail on the different aspects, etc. As I just mentioned, we're going to offer you some drinks with some little nibbles. Maximum roughly 1900 will we close the shop for that, but we'll see how many of you are still around. Tomorrow at 9 o'clock we'll start again. And then tomorrow morning, we got 2 more sessions. And then in the afternoon, we got 1 more session with, again, much more practical aspects, as well as the human elements in all this, etc. So with that said, I hope you had a good day. Thank you all for your time, for the good presentations and questions. Have a great evening and hope to see you all tomorrow. Yeah. And before I forget, most of the presentations that you saw today, all the ones up to the coffee break this afternoon, are already on the website. Yeah. So don't hesitate to tell all your social media friends about it. Thank you again and see you tomorrow.